Good morning, good afternoon, and good evening to you all. Welcome to AWS Immersion Day with special focus on SAP on AWS. We have people joining from 3 continents in today's event. It's wonderful to have you all on this event. My name is Hari Vyakanam from YASH Technologies, and along with my colleague Nimisha, will be moderating this event. So before we jump into introductions and the agenda, I would like to take a moment to discuss a few housekeeping items. For those who are not familiar with the GoToMeeting tool, if you take a look to your right, you'll be able to click on a chat box to raise any questions. And these questions will be answered either by moderators or one of the panelists during the course of the presentation. We will be recording this event today, and by continuing to stay in this workshop, you are consenting to be recorded. For any questions related to labs or related to your actual work, we will be replying to your questions privately if any sensitive information is to be shared. Otherwise, it will be publicly replied. So without any further delay, it is my pleasure to introduce you to very knowledgeable and experienced panel of solution architects from both AWS and YASH Technologies. I'll start with my good friend Arun Sivdas. Arun from AWS, please go ahead and introduce yourself. You're on mute, Arun.
Hello all, I'm Arun Shivdas, a partner solution architect specializing in SAP from AWS. I have a decade and a half years of experience in basis, in cloud, and I help partners and customers in designing their solutions, validating them, and cost optimization and all. Thank you.
Thank you, Arun. I'll invite Venkat Atavarthi, take over.
Hello, everyone. This is Venkat here. I'm a senior partner solution architect with AWS. I have over 15 years of experience in SAP and in cloud platforms. I engage with customers and partners, help them implement best practices, and make sure they make most out of their cloud. That's about me.
Great. Srinath, over to you.
Thanks, Hari. Thanks for the opportunity. Hey, everyone. I'm Srinath Medhi. I have 15 years of experience in providing architecture solutions, operations, and various things in SAP world. I'm with AWS, where I work as a partner solution architect specialized in SAP. I help my partners and customers to bring their SAP workloads to AWS platform. Thanks for the opportunity, and looking forward to have a great session with you today.
Thank you, Srinath. I'll now call upon my colleague Sridhar Oraganti to introduce himself.
Hey, good morning, good afternoon, good evening, wherever you are. Thank you for joining today's session. My name is Sridhar Oraganti, and I lead the SAP Development Integration and Technology Services from YASH. I am based out of Princeton, New Jersey, and I have been in the SAP world for almost 24 years now. Thank you.
Vikram, over to you.
Hello everyone, this is Vikram Kankam. I have overall 18 years of experience. I'm a solution architect working with YASH Technologies for the last 10 years. I have experience in moving SAP workloads to AWS Cloud. Thank you.
Great, thank you. And Kiran, over to you.
Yeah, hi, this is Kiran. I'm a solution architect at YASH Technologies, and I have 15 years experience in SAP, and I have been delivering in workloads, migrating SAP workloads to AWS. Thank you.
Thank you, Kiran. So without any further delay, I will request my colleague Sridhar Oraganti, who is our SAP's practice leader, to walk you through the agenda and also introduce YASH Technologies to everyone. Sridhar, over to you.
Thank you, Hari. Once again, thank you all for joining the session. I'll quickly get onto the agenda for today. So the agenda is broken down into small little modules. As you see, I mean, we are starting the session with introduction to the initial core services for SAP on AWS, and our friend from AWS, Arun, is going to talk through that, and immediately followed by a quick lab session wherein we will actually take you through the AWS platform, where you can actually how to start your activities, how do you set up VPCs and things like that. Both personnel from AWS and YASH will actually take you through the lab session. We will have a quick break after that, and then followed by the SAP workloads and architectural patterns. Once again, this is going to be covered by our partner AWS team, I mean Venkat from AWS team, and then how SAP HANA workloads are going to look like on the AWS. That is what is going to be covered by, once again, Srinath from AWS. And then there is going to be a lab session wherein we will show you and take you through how to deploy SAP HANA databases on AWS. And then we will take a quick break, followed by how introducing you to how to migrate SAP workloads to AWS. And this is going to be taken up by Kiran and supported by the rest of the team. Kiran is from YASH, and Vikram and other team members will support. And we also have set up some time for some questions and feedback and quiz, followed by a small quiz. So please request you all to participate in the quiz session as well. That is a quick agenda for today. Please, as Hari was also mentioning, please use the GoToWebinar chat sessions and other tools available to quickly reach out to any of the moderators or any other technical experts to get any of the questions answered. Without further ado, I'll quickly introduce YASH Technologies as a company to start with. I'll not spend more time. We have been in IT business for more than 25 years, and majority of our services and half of our revenues also come from SAP oriented services. And we have around 6,000 employees globally. We will also have a look at, I mean, where all we are located quickly, but we are headquartered in East Moline and Chicago, in both the places in Illinois. We have been a partner of choice for quite a lot of customers. I mean, a few of those, and many of those are Fortune 500 customers, just to name a few: John Deere, Monsanto, Merck, Stanley Black & Decker, CRL, and so on. We have 40 plus campuses globally. We will have a look at, I mean, what we do there, and then we have been acquiring also multiple other companies, and each of these focus on various different services. For example, ASIA focuses on our Pega platform related services. SIFA MI is our digital factory related services, and so on. So there are quite a lot of focused small little organizations also under the YASH group. So these are the various different locations. I mean, YASH is in Chicago, Illinois, and East Moline is where our headquarters are. And there are quite a few locations. I mean, I am joining you all today from our Princeton office in New Jersey, and Kiran is based out of India. Vikram is based out of Auburn, Mass locations, and so on. We generally are wherever we have been providing services to our customers, we have actually opened our offices there. So in all of these locations, we do have some of the other customers where we have been serving them for quite some time. Quickly, to get onto the SAP Practice overview, we have been, as I was mentioning, SAP has been one of our primary focus areas, and half of our revenues come from SAP related services. And we have been in the SAP business for more than 25 years. And while we provide almost all the various different services under SAP, we also have quite a lot of qualified S4HANA certified and S4HANA qualified industry solutions targeted for individual industries, manufacturing, plastics. These are all our solutions that we developed and got certified by SAP for even S4HANA. On the analytics space, we have quite a lot of expertise, and we continue to work with SAP and also quite a lot of our customers implementing the analytics solutions using the newer technologies like SAC and the older a little BW, a little older on BW and before HANA kind of systems. When it comes to the infrastructure services, we will also see that, I mean, we also not only provide services, I mean, to migrate customers' landscapes to any of the clouds, I mean, more so on the AWS, but we also are a hosting partner for AWS. So, I mean, we actually kind of help customers to host their systems through our AWS partnership as well. So without getting into the other details, I mean, there are quite a lot of, I mean, SAP related services. We have been doing big on the blockchain, IoT, big data. There are some sessions coming up, I mean, on these areas as well, in the digital manufacturing space and things like that. So most likely, I mean, we would be able to actually share that information just after this session is over. Moving on, we have been a partner of AWS for almost 5-6 years. I don't exactly recall, but I mean, we have been a partner of AWS for a long time. We are an advanced consulting partner, not only on the AWS side, I mean, but also we have been a partner on the SAP side for a long time. So that actually puts us in a very sweet spot in between, wherein we actually kind of help help customers and also be able to help customers migrate their SAP workloads to AWS. Not only just migrating, but also, you know, managing the workloads once those are moved to SAP by AWS, and then, you know, continue to support those workloads also. I mean, hosting, migration, and continuous support. As part of YASH's partnership with SAP, there is another partnership that we also carry with AWS that is called as MAP, Migration Acceleration Program. This is an AWS specific program, or rather a partnership that was rolled out to a handful of partners in the US. We are one of those, and as part of that, I mean, we also help customers accelerate their migration of workloads to AWS. In that context, our migration workloads follow a YASH Ascent framework, which we'll actually get into one level of detail in the next slide, wherein the YASH Ascent, let me quickly get onto that, for example. Before that, rather, sorry. YASH SAP Migration Factory, or YASH SAP MAP, the Migration Acceleration Partner Program that we have with AWS, helps customers in getting some accelerated funding with the help of AWS and YASH, and we would be able to actually work with the customers to see how we can not only accelerate the migration, but also be able to fund some of those activities. That is a joint exercise that is taken up with AWS. So YASH Ascent is a framework using which we would be able to actually help customers migrate their SAP workloads, especially using in-house tools, templates that we have come up with in conjunction with some of the AWS tool sets also that are available. And we have some automated scripts right from forming the AWS cloud and set up the cloud, and all the way up till migrating SAP workloads. There are quite a lot of automation activities in conjunction with our internal DevOps teams that we have developed by using some proprietary tools and also with the AWS tools. So we can actually get into some details, and we would be able to reach out to you for any help that you would need, and also be able to answer any of your questions around YASH Ascent Factory and YASH Ascent SAP Migration Factory program, either during this call or maybe in the subsequent discussions. With that, I will hand over the floor to Arun to take us through the rest of the information and precisely around module 1. Arun.
Thank you, Sridhar. Yeah, let me share my screen. Can I be made the presenter? So let me know if you can see the slide and not my GoToWebinar menu.
Yes, Arun. We are able to see the screen.
Okay.
It is currently on the YASH and AWS partnership screen.
Yep. So hello all, I'm Arun Shivdas, and I would be, I like to this session to be bidirectional. So if you have any questions, please put it in the comment chat. My co-host would respond to these queries in chat. So we can also answer to the queries in the end. So today, as part of module 1, I'll be talking a little about AWS, followed by SAP's relationship with AWS. So in this module, we would be discussing why SAP on AWS, and in the subsequent modules you will be exposed to how and which components you would be using to build a successful SAP on AWS. Again, we are only scratching the tip of the iceberg. uh, at SAP on AWS, the possibilities are unlimited when you marry the SAP data with AWS advanced services like machine learning, artificial intelligence, use advanced analytic tools, and you can mine the data, hidden data from SAP, and which would help to give new business insights into the hidden data. Now, irrespective of the size of your organization, AWS provides a highly flexible, cost-effective, scalable, and easy-to-use cloud computing platform. With AWS Cloud on-demand pricing model, you only pay for the services you consume. You have the capability to scale your usage at any given time as per your business requirements. Typically, we see that the demand increases for SAP customers during month, quarter, or annual closing compared to your regular times, and AWS help you to meet these demands. Now, let me talk about what differentiate AWS apart. For AWS, the security is job zero. AWS help you to maintain a fine-grained control over your resources. You can control who needs to have access to which service or which part of the service and what type of access. AWS offers the widest range of compliance certification, helping you in your compliance journey, whether it is PCI DSS, HIPAA, or any other compliance requirement. Now, with over 175 services, AWS offer broadest and deepest range of services for any of your cloud workload, which we'll be discussing a little bit in our next slide. And we are continuously adding to the list with new services or adding new features to this list. And many of these innovations have been customer driven, where the pace of innovation was driven by the customer needs. As our CEO says, there is no compression algorithm for experience. We have been building and managing cloud since 2006. Customers have selected AWS for all these years because we have proven ourselves committed to their success. AWS today has the largest global footprint with 24 regions and 77 availability zones. This allows customers to expand to new geographies faster. In contrast to the market philosophy, where the inflation drives the prices up, we are proactively reducing prices from time to time. To give an instance, we have reduced 67 times since 2006. So we do this by passing the benefits of innovations and economies of scale to our customers. Now, AWS created an extensive SAP ecosystem jointly with SAP and our partners like YASH. Now, as discussed briefly in last slide, we offer a broad set of services, including compute, storage, managed database, analytics, networking, and a plethora of applications. These services help organizations move faster, lower IT cost, and scale. AWS is trusted by largest enterprises and top startups to power a wide variety of workloads, including web, SAP, mobile applications, game development, etc. Now, these services are continuously updated and improved upon, and AWS is regularly adding new services based on customer feedback. AWS has developed the broadest collection of services available from any cloud provider. Our approach to regions, availability zones, points of presence provide global coverage for high availability, low latency applications. Foundation services across compute, storage, security, and networking, which we will be discussing today, offer customers flexibility in their architecture. We have a full spectrum of options to meet most price to performance scenarios. We offer the capability of both managed and unmanaged database options. The offerings of analytics and application services enable advanced data processing and workload. For instance, AWS Redshift, our cloud-based data warehouse solution, is the fastest growing service in the history of AWS. Our management tools offer a lot of insight and flexibility to let you manage your AWS resources through either our tools or the management tools you are already familiar with. A recent expansion into enterprise applications has been entirely driven by customer feedback on where they would like us to deliver the value. Now, this slide may look a little bit dense, but for most of our customers, they start with the basic infrastructure services like compute, storage, networking, and as they mature on cloud, they start using higher and more varied services. Now, as discussed previously, we have the largest global footprint. Customers that run SAP on AWS gain all sort of advantage in terms of flexibility, agility, and lower TCO. To help you in understanding this value proposition, I would like to start with its foundation, that's region and availability zones. So regions are geographically dispersed in different areas of countries and help customers place their infrastructure closer to user base or to ensure that they comply with the data residency requirements. Data always stay in region unless customer choose to move. Each region is interconnected by fully redundant, high bandwidth, low latency networks. Each AWS region consists of multiple isolated and physically separate availability zones. All availability zones in region are again interconnected with high bandwidth, low latency networks. Now, availability zone is a group of logical data centers. So each availability zone is one or more discrete data centers with redundant power, networking, and connectivity. Availability zones provides you with the ability to operate your critical applications like SAP, which needs to be highly available, fault tolerant, and scalable than you can by using a single data center, by letting you spread your infrastructure across multiple availability zones. Availability zones allow customers to operate in the sweet spot of both resiliency of performing real-time data replication and the reliability of multiple physical locations. Each availability zone is placed in a low natural disaster zones with distance of approximately 100 miles or less between each of them. This low distance coupled with high bandwidth network ensures low latency of replication of your data across availability zones. This ensures a high available environment with zero or near zero downtime. We also offer over 220 points of presence. These are edge locations for caching contents closer to your user base. Now, as discussed previously, the AWS Cloud Security Infrastructure is architected to be one of the most flexible and secure cloud computing environment available today. Security on AWS is very similar to security in your on-premises data center, but without the cost and complexities involved in protecting facilities and hardware. AWS provides a secure global infrastructure plus a range of features that you can use to help secure your systems and data in the cloud. If you want to learn more about it, you can visit our AWS Security Center. Now, AWS offers a wide range of certifications and attestations covering compliance program for around the globe. You can leverage these certifications and attestation to meet the additional compliance programs. Again, AWS works on shared security responsibility model. So for the data in cloud, you will be responsible for, but the data, we take care of the security of the cloud. Now, to add to our previous discussion, we talked about, let me talk about the differentiator of AWS compared to your on-premises solutions. So with respect to 4 pillars, that is cost, resource utilization, planning, and deployment. So on cost, on-premises require a large capex and needs to be planned in advance. This restricts your scope to do any experimentation, as it is difficult to justify these costs, and sometimes new features and ideas arise during the system operations. Now with AWS, you trade capex with variable expense and only pay for the resources you use and as you use. Now with on-premises, you need large amount of resources, both capital and personnel, to maintain the on-premises data centers. Also, as you have predetermined limited resources, ad hoc requests to maintain. So ad hoc requests require you to prioritize your workload at peak level of activities. Now with AWS, you innovate faster as you focus your resources on applications that differentiate your business instead of undifferentiated heavy lifting of data center management and all. In on-premises, as you need acute planning of resources ahead, you need to estimate your future workload accurately ahead of time. If it is underestimated, you end up with overloaded and sluggish applications. And if you overestimate your sizing, you have highly underutilized resources sitting in your data center for which you have paid higher than what you require. Now with AWS, you plan for what you need today, knowing very well that you can scale up or down as your business requirements change. Also with on-premises, you need a long lead time before an application can be deployed. Now this would be a longer if it is in a new geographies where you need to start from real estate planning to all the way to installing SAP application. With conservative estimate, this takes upward to 6 months. Now with AWS, you can go global in minutes. You can have application configured and running in few hours. Now let me talk about specifically on SAP on AWS. So SAP is synonymous with mission critical mission critical business application that needs extreme dependability, needs to be highly available. Also, the SAP application and ecosystem need to be highly extendable and customizable. But this comes at a cost. So SAP solution tend to be highly integrated and connected with IT infrastructure. Also, many customization happens in SAP environment over time, making it very complex and hard to upgrade. There is no denial of the fact that SAP is expensive. With all this comes the processes and procedures which helps in protecting SAP backbone, but this also makes it very inflexible, cumbersome, and time consuming to maintain. Inevitably, it's hard to keep SAP solutions current. All of this led to an inertia in transforming to the digital core. This is where SAP on AWS bring value addition. Now, AWS and SAP have a strong partnership and history of collaboration and rapid innovation. AWS has the longest experience running SAP solutions on the cloud. We have 13 plus years of relationship of collaboration and innovation to enable SAP customers to accelerate their digital transformation. Also, SAP has been AWS customer since 2008. AWS has been certified and supported since early 2011. We will be looking into it shortly. Now, running critical SAP workloads on AWS enables your business to be more agile, cost-effective, and secure than running them on-premises. AWS provides cloud-native services that streamline your ability to adopt emerging technologies and enable greater innovation and faster time to value. By running SAP workloads on AWS, you build once, deploy globally. Now, this you do by using templates and machine image with which you can deploy you can redeploy an environment that's fully built. And you deploy this infrastructure in minutes with few clicks in management console or by running code or command line commands. We will be doing as part of the lab. We would be deploying infrastructure, so you'll see that them in action. So you scale to demand to meet the demand. Now, by creating additional environments or resizing existing environments on the fly with no downtime. You improve your security position for your most critical systems by creating identity and access management rules that enables secure communication between services without copying the keys. You strengthen operational reliability by running temporary stress environments and then decommissioning them when you are done. You can combine SAP with AWS services to derive additional values. Now, SAP and AWS have been innovating on the cloud for over a decade. Now, this slide shows a roadmap of this journey. So let me talk about a few of them. So in 2012, customers started their SAP on any DB journey. By 2015, we had hundreds of customers running SAP on any database on AWS. Around 2016, we launched AWS X1 instance. Now, these were the only HANA offering HANA certified system, compute system which could support 2 terabyte scale up or 15 terabyte scale out at that time. By 2017, the X1E instances were launched. Now X1E instances came with 4 terabyte scale up or 50 terabyte scale out. Around the same time, AWS partnered with SAP and other partners to create a FAST program. The FAST stands for the Fast AWS and SAP Transformation Program, with SAP supported tools for migration to AWS. Also, we began hosting the SAP Cloud Platform, where today we continue to have the most global and service coverage. By 2018, we had thousands of customers running SAP on AWS. We also launched high memory cloud native instances for HANA with up to 12 terabyte memory. In 2019, we launched 18 and 24 terabyte high memory cloud native instance. In 2020, we launched the only 100 terabyte B4 HANA offering, followed by the only 48 terabyte S4 HANA offering. Both continue to be the only native cloud enabled options available today. In solution space, we launched dozens of AWS solution partners offering. So last year we launched Launch Wizard for SAP. Now with this, you can launch a fully installed S4 HANA, B4 HANA, or SAP NetWeaver with high availability in under 2 hours. I mean, the people who are coming from the basis background can understand that, to have a fully highly available, fully installed SAP, it takes a lot of time, right? So the entire solution Launch Wizard takes care of it in under 2 hours. We also launched AWS Backend Agent, with which you can send your HANA backup directly to AWS object storage. And this is integrated with Launch Wizard. Now, the benefit of doing this would be, your data, you are not, provisioning any extra hard disk for backups. So your backups are directly being sent to S3. Also, S3 having a higher durability this ensures that your backups are more safer. We are excited to share that more than 5,000 active AWS customers run SAP on AWS, and over half of these customers have deployed SAP HANA-based solutions on AWS. Now, that's massive. Now, across the board, these customers are seeing that AWS offer them choice. Their stories range from lift and shift of existing ECC environment to complete S4 HANA transformation and innovation on top of SAP cloud landscape with artificial intelligence, machine learning, IoT, data lake, voice, etc. To give examples, Coca-Cola and Cambridge University Press, who have gone all in on AWS, including migration of their entire SAP environment to AWS. Others like NG, Liberty Mutual, Line, IDEO, Utopia, and few others have migrated SAP to AWS and are now implementing additional AWS services for innovation in their SAP environment. The SAP on AWS pace of innovation mirrors the broader AWS pace of innovation and includes a steady stream of offerings for customers. SAP continues to choose AWS to power their own cloud services and other offerings as a customer. Here are a few of the examples of few of the co-innovations. So for SAP customers that want to quickly create analytical views across all their SAP solutions and AWS native services, SAP Analytic Cloud or Data Warehouse Cloud can be deployed and configured at a lightning speed, and this runs exclusively on AWS. SAP hosts their HANA as a service on AWS for developers who want to quickly get their work done on HANA. SAP and AWS work together to enable native AWS IoT core integration with SAP IoT Core. For customers with GDPR or other regulatory concerns, SAP now offers SAP Data Custodian that secures SAP data as it flows to and from SAP and AWS environments. The SAP Service Cloud integration, SAP Service Cloud integrates with AWS Connect and provides customers with a more effective way to handle service calls and orders. Our relationship with SAP extends well beyond infrastructure as a service and instance certification. Here are some of the examples of SAP application that runs on AWS. So core SAP cloud offering like S4HANA, SCP, that's SAP Cloud Platform, HANA Enterprise Cloud HEC, these runs on AWS. SAP's NS2, which hosts public sector customers like Navy, leverages AWS Cloud. So many of the SAP's acquired SaaS offering were built on AWS, like SAP Concur, Qualtrics, Gigya, SAP SuccessFactors, and all. Now, all of these services either run exclusively on AWS or we have a significant presence. Now, this ISG provider lens quadrant report shows the standing of different public cloud provider for SAP HANA infrastructure service in 2020. AWS has maintained the leader position consistently year after year. As per the ISG, with AWS, clients have most choices, highest capacity infrastructure, and extensive migration experience and client successes. Now, AWS and SAP have worked closely together to ensure that SAP solutions are fully supported by SAP for production deployment in AWS cloud, for instance, SAP HANA. Now, AWS and SAP have worked together closely to certify the AWS platform so that companies of all sizes can fully realize all the benefits of SAP HANA in-memory computing platform on AWS cloud. SAP customers have the ability to leverage very high scale-up and scale-out setups for their SAP S4HANA and B4HANA workloads in AWS cloud and take advantage of the innovations of AWS Nitro system, a combination of purpose-built hardware and software components that provide unparalleled performance, security, isolation, elasticity, and efficiency. AWS offers a secure and scalable global and low-cost cloud computing to give your customers a responsive, low latency SAP Commerce web experience. AWS provides the core infrastructure services like compute, storage, load balancing, content delivery, etc. Now, these services enable you to rapidly deploy and efficiently manage your SAP Commerce environment on the AWS cloud. AWS and SAP has worked together to certify the AWS platform for SAP Business Suite solution. Enterprise customers can run their mission-critical SAP application, including SAP ERP, CRM, HCM, PLM, SCM, SRM, and a complete SAP NetWeaver, ABAP, and Java technology stacks on AWS cloud. Enterprise can use AWS as an extension to their existing IT infrastructure or a complete virtual data center in the cloud. New and existing SAP Business Suite customers of any size can run SAP production and non-production workload on flexible, secure, low cost, and elastic AWS cloud infrastructure. Similarly, small and medium enterprises can now access all the business benefits of SAP Business All-in-One solutions without needing to make long-term commitments or costly capital expenditure. Small businesses can now access all the benefits of SAP Business One solutions on AWS. Similarly, AWS supports SAP Business Object Solution, mobile solutions like SAP Mobile Secure, SAP Mobile Platform, etc. Now, AWS supports major enterprise level operating system for SAP. Now, these are SUSE Enterprise SUSE Linux Enterprise Server / Red Hat Enterprise Linux RHEL, Microsoft Windows Servers, Oracle Enterprise Linux. For SLES and RHEL, the machine images that are available in Amazon EC2 provides high availability add-on features for SAP applications. You can purchase these images via AWS Marketplace. Alternatively, you can bring your own license also. Similarly, apart from the SAP databases like SAP HANA, MaxDB, Sybase, AWS also supports a number of database applications for SAP. Now, these includes Microsoft SQL Server, IBM DB2, Oracle Database. For your hybrid commerce, Amazon Aurora is also supported. Let me get into the next section. So in this section, you will be introduced to core services for running your SAP workloads on AWS, starting with networking. You can easily connect to AWS from your on-premises environment as well as run your workloads natively in the cloud. The AWS approach to networking provides you with the ability to implement multi-layered secure environment for your critical SAP workloads. As part of module 1, we would be essentially talking about 3 categories of resources. Network resources. Now, these would be one of the initial resources that you would be deploying for your SAP workloads. You would be defining your network layer with Amazon network resources like Amazon VPC. You will connect your on-premises to AWS using AWS services like Direct Connect and AWS VPN. Then we will be talking about compute resources. So this is what correspond to your servers in on-premises term. SAP workloads would be hosted on Amazon EC2. Then we'll talk about storage resources. Now we'll be briefly touching upon block storage services, Amazon EBS. Then we'll talk about shared file system, Amazon EFS and Amazon FSX for Windows, and then object storage, Amazon S3. Now, when you are ready to start running SAP on AWS, the first step is to create an AWS account. So if you don't already have one, then select a region of for your deployment. Next, you will create one or more Amazon VPC where SAP system will be deployed. So Amazon VPC is an isolated section of the AWS cloud to run your SAP applications. It provides you with the integration back to your on-premises environment for end user and application connectivity. Amazon VPC provides you with a set of tools that enable you to completely control your networking environment. You can select your own IP address range, create subnets, configure route tables and network gateways. Amazon VPC includes unique security features that enable you to create additional layer of defense in your environment at both the subnet and instance level. Amazon VPC also provides a number of connection gateways and endpoints that let you manage access and restrictions for your internet and private access to resources in your VPC. You can easily customize the network configuration for your Amazon VPC. For example, you can create a public-facing subnet for your web servers, or for your backend systems such as database. You can put them in private subnets with no internet access. And you can leverage multiple layers of security, including security groups, network access control lists, NACLs, to help control access to Amazon EC2 instance in each subnet. Additionally, you can create hardware virtual private network or direct connect connections between your corporate data center and your VPCs and leverage the AWS cloud as an extension of your corporate data center. Now, to access AWS from your on-premises environment, you can leverage AWS Direct Connect or AWS Virtual Private Network, AWS VPN. This also applies to end users to SAP communication, where end users are on-premises and instances are in AWS. In the context of SAP deployment, AWS VPN may be deployed in the initial stage of a project. And then as the bandwidth requirements become known and customers may transition from AWS VPN to AWS Direct Connect. Now, AWS VPN is a secure connection that runs over the internet. So you can securely extend your data center branch office network with Amazon site-to-site VPN connection. So it basically uses IPsec communication to create a encrypted tunnel, VPN tunnel between two locations. Now, as this connections transfers the internet, the speed is determined by your internet connection and the number of hops that you will have in internet. Now, in case you need a dedicated line, you can go for AWS Direct Connect. So AWS Direct Connect is a dedicated line that you build with our telecommunication partners, and can provide you high bandwidth and low latency, and your bandwidth, and you have a more control over your bandwidth requirement. The private connection, this private connection can reduce network costs, increase bandwidth throughput, and provide a more consistent network experience than internet-based connections like AWS VPN. Now, you have several options of establishing connectivity between SAP application and other systems or resources. So, for instance, in Internet Gateway, which is basically a horizontally scaled, redundant, and highly available VPC components that allows communications between instances in your VPC and the internet. It imposes no availability risk for bandwidth constraint on your network traffic. So what you need to do is you need to create a route to your internet gateway to route your internet traffic to internet gateway. Then you can use network address translation gateway to enable instances in private subnet to connect to the internet or other AWS services, but you can prevent the connection where it is initiated from external sources. For this, you will create a route in the internet route in route table, and you associate a NAT gateway as the endpoint for internet traffic. This is particularly used for where you have a scenario where you need to download the patches and all. So this is where you will be using a NAT gateway. A VPC endpoints enable you to privately connect your VPC to supported AWS services like S3, DynamoDB, etc. without going over the internet. So traffic between your VPC and other services does not leave the Amazon network, and you access services like S3 internally. A very important question that customers have is how to leverage Amazon VPC features to keep their SAP environment safe. So Amazon VPC includes security details that you must set up to enable proper access and restriction for your resources. Amazon VPC provides the many features that you can use to control security for your VPCs. Now, these include security groups. Now, security groups acts like a firewall for associated Amazon EC2 instances, controlling both inbound and outbound traffic at the instance level. They work on a 5-tuple filter. This includes source IP, your source port, destination IP, destination port, and the protocol for communication. Also, keep in mind that security groups are stateful. That means if a connection is allowed for incoming, the outgoing connection is also enabled. Then comes network access control list, that is NACLs. Now the way the security group acts as a firewall for the instances, NACL acts as a firewall for the associated subnet and controls both inbound and outbound traffic at the subnet level. Now, NACLs compared to security group is a stateless firewall. So you need to, exclusively allow both incoming and outgoing filters for the communication. Route table consists of a set of rules called routes and determine where network traffic is directed. So if in a scenario where you need to ensure that you need to sniff the packets that goes in and out of, you can in the route table you can define the hops for your packets accordingly. Now, similarly, flow logs, is you'll be using a lot if for troubleshooting purpose. Like so, flow logs capture information about IP traffic going to and from network interfaces in your VPC. This is very helpful, as I said, for performing troubleshooting and understanding what kind of traffic is flowing into your VPC, what kind of traffic is being rejected. Now, let me talk about few of the VPC design patterns in SAP use case, right? So the first is single VPC with only private subnets. Now, this design pattern shown is used to create a network environment that is only accessible from an existing internal network, such as internally facing or back office systems. The VPC design is appropriate for customers who want to utilize their own internet service providers to control all internet-based traffic and to forego public IP addressing capabilities from AWS. SAP systems and subsystems reside either in single or multiple private networks. The diagram shown shows only one private subnet, but you can architect as many private subnet as you need. For example, you can have separate private subnet for dev, QA, production systems. And again, another example would be you can split across your SAP application across multiple subnets where you can have a different private subnet for your database. For your SAP application, you use a different subnet, and for any other enterprise application, you use a different subnet. Security groups and NACLs must be set in this architecture to enable communications between systems residing in multiple subnets. A single VPC with public and private subnets. Now, this design pattern is used to create a network environment that has the ability to communicate with both internal, that's privately routed, and external, that's publicly routed resources, using a combination of public and private connections. The design is ideal for SAP workloads that need to accommodate a combination of public and private routing needs, such as an internet-facing multi-tier web application supported by databases. SAP systems such as Web Dispatcher, Database, and Application Servers reside within the same private subnet. Each of the instances reside within their own security group. Alternatively, the pattern could be modified to use separate subnets so that the database and application servers each resides in their own subnet. The advantage of using separate subnet for database and application server is that the database is more protected by shielding its subnet with separate route tables and network ACLs. Your internet-facing applications like SAP Router or NAT Gateway, your NAT instances are placed in public subnet. Only specified public IPs are from SAP are allowed to connect to the SAP router. Now, Elastic IP that you see here is a permanent external IP that is reachable over the internet. Now, the next design pattern is with multiple VPCs. Now, this design pattern is useful for customers who require multiple VPCs for security, billing, regulatory, or other purposes. And want to integrate AWS resources between their VPCs more easily. For example, you may be asked to run SAP production system in one VPC and an SAP non-production system in another VPC. More often than not, these different VPCs need to communicate privately and securely with one another to share data or applications. Now you can have production system reside in a separate VPC from the non-production system. When deploying multiple VPC in one account, consider that Amazon VPC doesn't route traffic to another VPC by default. Systems in different VPCs need to communicate with, sometimes systems in different VPCs need to communicate with each other. So for example, in SAP context, you will have the transport file system, right? That needs to talk to both production and non-production landscape. To enable this communication, a VPC peering must be set up between each pair of VPCs. Now, the final design pattern we're discussing is the multiple account. So many SAP customers create multiple AWS account to streamline billing and restrict access to various environments, such as for development, staging, and production across different business and application teams. To expand on the production and non-production scenarios that we described before, assume you have one account for production system and a separate account for non-production system. With the now this is mostly the recommended pattern because you are able to restrict the blast area of not properly configured IAM by having multiple accounts. But the downside is with the increase in the number of accounts, you must efficiently manage network and security policies across your application environments. Now, as shown in this diagram, you create separate VPCs for each account. The account owner is responsible for connectivity and security of each Amazon VPC. The multi-account nature should be taken into account when setting up the communications between different accounts. I hope that we are getting questions and my co-hosts are able to respond to it. So now once you have created one or more Amazon VPCs where your SAP system will be deployed, you start deploying computing instances into them in order to host SAP systems and to provision computing capacities. So Amazon Elastic Cloud Compute is equivalent of server on premises terminologies, or VM if you have been using VMware. The EC2 provides secure, resizable compute capacity in the cloud. It has a simple web service interface. It provides you with complete control of your computing resources and let you run on Amazon's proven computing environment. EC2 is designed for scaling deployment and optimizing workloads. So Amazon EC2 provides you with complete control of your computing resources. You can obtain and configure capacity with minimal friction and run your SAP workloads on proven Amazon computing environment. Resources can be started, terminated, and monitored as needed. And you can increase the availability by deploying instances across multiple physical locations. That's availability zones. Now, Amazon EC2 is designed to make web scale computing easier for developers. It provides user with scalable compute capacity. You have complete control of your instances, including root access and the ability to interact with them as you would with any machine. With Amazon EC2, you can quickly scale vertically, that is scale up or down, or you can scale horizontally, that is you can add more instances, or you can stop instances if you don't require them. Now, this flexibility enables you to shorten procurement cycles from weeks or months in your on-premises instance scenarios to minutes. You only use what you need and when you need it. Also, you pay a very low rate for compute capacity than you actually consume, right? The Amazon EC2 passes on to you the financial benefits of scale. So as Amazon continues to make price reduction as its scale increases. Amazon EC2 supports, as I discussed previously, supports RHEL, SUSE, Windows servers, which are x86 based operating system, typically deployed for SAP systems. So you choose from your familiar operating systems. You will be doing an EC2 deployment as part of the lab in some time. Now, some key concepts and terms that you will be hearing as part of today's session is, first you will be hearing about AMI. So AMI is Amazon Machine Images that are pre-configured system templates containing the software configuration like operating system, application server, OS hardening that is required to launch an instance. So AWS provides marketplace AMIs, plus you can also create your AMIs where you can bake in your corporate hardening and you can reuse for your corporate requirements. Then you'll be hearing about instance types. So instance types are a defined virtual machines configuration that offer different compute and memory capabilities. An instance is a virtual machine launched from an AMI. Security group, as discussed previously, acts as a firewall that controls the traffic allowed to reach one or more instances. When you launch an Amazon EC2 instance, you associate it with one or more security groups. Now, Amazon EC2 offers a number of instance types for deploying SAP solutions. So each instance type is optimized for different use cases with various combinations of CPU, memory, storage, and networking capacity. This gives you the flexibility to choose the appropriate mix for your applications. Each instance type includes one or more instance sizes, allowing you to scale your resources to the requirement of your target workload. Within each types of family, there are multiple sizes like small, medium, large, X large, 2X large, etc. You can run a non-production SAP environment on any Amazon EC2 instance type, but you must use one of the SAP certified Amazon EC2 instance types for production SAP workloads. SAP certified Amazon EC2 types have the SAPS rating, which can help guide you in deciding which instance types fits the requirement for your SAP application. Now, the different families of instance types are general purpose instances, which provides a balance of compute, memory, and networking resources, and can be used for a variety of workloads like your SAP app service. Then we have compute optimized instances that are ideal for compute bound applications that benefit from high performance processors. Sometimes you use this for ASCS and ASCS, ERS, SAP Web Dispatcher, etc. Then you have memory optimized instances that are designed to deliver fast performance for workloads that process large data sets in memory. Then you have Amazon EC2 high memory instances that are purpose-built to run large in-memory databases, including production deployment of SAP HANA in-memory database in the cloud. Now let us understand Amazon EC2 instance type naming convention. The first letter depicts the instance type. So C here stands for compute instance, M is for general purpose instance. The number that follows the first letter indicates the generation. As an example, M5 is the fifth generation of the general purpose instance type. The attribute after period depicts the instance size. Now this slide depicts the difference instance size and how instance size differs linearly with capacity and cost. So if you see here, M5 16x large is 16 times larger than M5 x large. Now, there are several ways to pay for your Amazon EC2 instances for SAP workload. Now, with on-demand, you pay for compute capacity by the hour or second, minimum 60 seconds, with no long-term commitment. Reserved instances let you make 1 or 3-year commitment, thereby receiving a significant discount over your on-demand instances. Now, these instances are useful for committed or baseline utilization. Now, with reserve instance type, you can choose standard, convertible, or scheduled instance type. Convertible reserved instance type provide you with the flexibility to change instance family, operating system types, and other attributes of the reserved instance while still benefiting from the reserved instance pricing. When you purchase a reserved instance, you determine the scope of reserved instance. The scope can be either regional or the zonal. A zonal reserved instance provide you capacity reservation in a specified availability zones. Then you have Amazon EC2 spot instance that let you take advantage of unused Amazon EC2 capacity in AWS cloud. Now, spot instances are available at 90% discount compared to on-demand prices, but these are not a preferred use case for your SAP, as it can terminate or stop or hibernate within a minute when your spot prices exceed the maximum price for your request. Then you have an Amazon EC2 dedicated host that allows you to use eligible software licenses from vendors like Microsoft and Oracle on Amazon EC2. So you can get the flexibility and cost effectiveness of using your own licenses. But also the resiliency, simplicity, and elasticity of AWS. The reserved instances tend to be the most commonly used purchasing option for Amazon EC2 instances for SAP workload. And in combination with on-demand instances for systems that have short lifespan. The steps to set up an Amazon EC2 instance for SAP are first you are setting up the prerequisites, including IAM role and etc. Then you have you will be creating an Amazon EC2 instance for SAP and setting up SAP AWS data provider for SAP. Then you will be doing resizing and modifying, and then you will be enabling auto recovery and other important configuration as per SAP recommendation or your organization's requirements. So let me talk shortly about AWS Data Provider. So AWS Data Provider for SAP is a daemon or a service that automatically starts with operating system and collects, aggregates, and exposes matrices to SAP platform. The AWS Data Provider is a mandatory component for receiving integrated support from SAP and AWS. Now it gathers information like AWS specific informations like your instance type, instance ID, and other metadata for the instances. It also get key system informations like number of processors, memory, disk configuration, etc. So SAP database, OS cockpit, and SAP support use this information gathered by the AWS data provider to analyze any performance issue. Now there are 5 modes of launching an EC2 instance. So EC2 management console, AWS command line interface, CloudFormation template, SDK and other programming toolkits, and then cloud development kits. In order to launch an Amazon EC2 instance with command line interface, you need image ID, number of instances that you want to launch, instance type, key pair to log in into your instance, and security group. Also, resizing servers in an on-premise environment is a task that can take days or even weeks to complete. With Amazon EC2, you can resize and modify your instances in a matter of minutes. You basically shut down your EC2 instance, change the instance type, and then change the instance type and then start the instance. So you get your EC2 instance back with all the configurations and setting as it was previously with a newer size. So once you have deployed your EC2 instance in one or more Amazon VPCs, we have we have to look at the storage offerings of AWS for storage services. So Amazon offers 3 broad categories of storage services: object, block, and file storage. Now each offering is designed to meet a different storage requirements. So block storage corresponds to concepts of disk or SAN in on-premises. Amazon EBS provides you with the raw storage. File storage corresponds to the NAS appliances in your on-premises that you use for file share. This is where you will use Amazon Elastic File System and Amazon FSx for Windows Server. Then you have object storage that is used to store immutable files such as your software dumps, backups, interface files, etc. So when you leverage AWS storage services for your SAP workload, you can protect your data with unmatched durability and security while running a much simpler infrastructure than you could achieve in your on-premises environment. So Amazon EBS offers a block level storage service. It is used for hosting SAP applications and databases, including database data, database log files, and backup volumes. So AWS provides multiple EBS volume types to meet IOPS and throughput requirement for SAP appliances. For example, GP2 and recently launched GP3 volume types provides general purpose SSD volumes. Where if you need a higher IOPS, you can go with IO1 and IO2 SSD volumes. Amazon S3 is an object level storage service that is typically used for storing SAP application backups. Amazon Glacier provides highly secure, scalable, durable, and cost-efficient data object storage that can be used for long-term backup and data archives required for compliance and for regulatory reasons. Amazon file system includes file system solutions include Elastic File System and Amazon FSx for Windows. Now these files storage system are useful for shared file system including SAP MNT, user SAP Trans. Now let's talk about how to transfer data in and out of AWS. So AWS offers numerous choices for data transfers to support migration and hybrid operations. The solution you will choose will depend on your use case and performance requirements. So AWS services for managing hybrid operations for data transfer include AWS VPN and AWS Direct Connect, which we already discussed previously. AWS Storage Gateway is a hybrid storage service that enable your on-premise applications to connect to AWS Storage Service, providing storage for files, volumes, snapshots, and virtual tapes in AWS. Similarly, AWS Amazon S3 transfer acceleration leverages edge locations to provide fast, easy, and secure transfer of files into Amazon S3 bucket. Now, this service is useful for situations where global users are required to upload data to a centralized bucket and where you need to transfer gigabytes or terabytes of data on a regular basis across continent. Now, as with traditional on-premises application, you can use multiple cloud storage options together to form a comprehensive data storage hierarchy for your SAP workloads. So thank you, and so any questions? Okay, so if we don't have any questions, and I hope that my colleagues have been answering your questions, so we will get into lab. So Vikram, can you take over? So we will be helping you in your lab. So Vikram will be running the lab with a screen share, and you can follow it. You also been shared the lab manual, so please follow that. Thank you.
Thank you, Arun. Thank you so much. That was helpful. So we're going to walk through the services, and let me start sharing my screen. Let me know if you can see my screen. So I'll give them 30 seconds so that everyone can kind of access the manual, the guide which has been provided as part of the session, where you can just pull up that so that I can walk you through. Okay. So I'm assuming that everyone has opened up this guide. So as part of this lab, I'm gonna walk you through the prerequisites and what is required for lab here, and also we're gonna see the services as Arun explained, what is required to launch an EC2 instance, what all is required. We're gonna have a hands-on introduction of AWS services where we're gonna create a VPC, create an IAM role, and create a AWS key pair to access. And we're going to create a RDP server instance. We're going to launch it, and we're going to log into the RDP instance. So as part of this lab one, we're going to create a RDP instance. Coming to the prerequisite, I'm assuming that you have required browser to access. So Google Chrome, Firefox or Edge, and for the any Mac iOS, you have to have the latest Safari. Okay. In order to access the lab, I think our team has already provided you a hash ID. Please get that hash ID. So I'm going to start the lab session here. So please copy the hash ID, and I'm going to go into the browser and start entering the hash ID here. So it should prompt you to the screen where the key is already encoded here. So you don't have to copy and paste it here. It should be already populated over here. Please accept and log in. Yeah. So the team dashboard should appear where you're going to go ahead and set the team name. So here I'm going to give my name, last name. Please set the team name. By doing so, it will be easy. If at all you are stuck anywhere, our panelists who are supporting us can pick up and resolve your issue by getting your team name. That would be an easy fix for them to identify who are having issues. So once your team ID appears, the team name appears, go ahead and click on AWS console. Okay. And on the left top, open AWS console. So here we're going to launch the EC2 instance using AWS console. As Arun has mentioned, we have multiple ways to launch the EC2 instance. So we're going to use the AWS console in this scenario. Click on this. Okay, let me close this. Looks like already logged in.
We can log out, Vikram.
Yeah.
Click on AWS. Click log out.
Okay.
Now you can close this and open the console.
Yeah. Thank you. Thank you, Kevin. Yeah. As you can see. So first of all, we're going to go ahead and create an Elastic IP as per your guide. So I would rather prefer typing here. Okay, go ahead and allocate the Elastic IP. This is the public IP which we're going to create and assign it to the RDP instance, which we're going to create. So on your screens, you might see the US East one. This is by default. We have already given that region. Whenever you're going to launch in your environment, you can select as per your region. Go ahead and allocate it. So the Elastic IP has been allocated. Next would be we want to create a VPC. I would prefer again go ahead and search for the VPC. Yeah. This screen should populate. I'll try to be as slow as possible, team, if at all you're having any issues. I will go ahead and launch the VPC wizard here. And I would go ahead and select the VPC with public and private subnet. Okay. Go ahead and select. Here I'm going to provide all the required information in order to create a VPC. The CIDR block, we have given a default CIDR block here. I'm sure according to your organization, whenever you're going to create, you're going to check with your network team, and whatever is applicable, you're going to have that entered here. Let's go ahead and create a VPC name. Again, as mentioned in the document, please make sure that your name is attached so that it will be easy for us to figure out if you're having any issues. I would rather, that would be my first name alphabet and last name alphabet. Okay. And the availability zone, I would choose the default one, US East, and the public subnet would remain same. And the availability zone, I'm going to select it. Okay. Earlier, whatever elastic IP you have created, please allocate that elastic IP here. Okay. Please go ahead and create the VPC in the end, right side corner. Okay, let me go ahead and fix this.
So
As
hello
using the
team,
VPC.
if you are facing any issues with logging into labs, please reach out to the organizers. We can help you in getting in.
Just give a minute. Once the VPC is created, then we're going to go and create an IAM role. See, someone is asking some questions. Okay. So once the VPC is created, please go ahead and click on this. Okay. Yeah. So so your VPC is created here. The next step would be to create an IAM role. Team, again, you can go to services and go look for the options. I would rather prefer to go and search here. That would be an easy thing. Okay. Click on IAM and roles. Yeah. Create a role. Select on EC2, common use case. Allow EC2 to call AWS Services. Select on that. Go to the next permissions. So as per guide, you should be selecting two roles here. One is Amazon S3 full access. Just copy and paste it here. Select this one. And the next role would be Amazon SSM Managed Instance Core. Please select that too. Go ahead to the next step. You can create a name here. I would rather prefer to go to the next step here and create a name for this role. That would be VK. Okay. You should make sure that these roles, both the roles are populated here. Go ahead and create the role. Now that role is created, the next step would be to create a AWS key pair. Yeah. So this key pair will allow us to log into the RDP server, create a key pair. Yeah. Please mention your name, your initials. Okay, the file format we would choose is the PERM. Once the key pair is created, the PERM file will be downloaded and should be stored in the default location in the downloads. So the next step would be to create the RDP server, the instance type. On the left side, if you can see the instances, please click on that. On the right side corner, you should be able to see the Launch Instance tab. Please select that. Here, I would look for Windows Server 2019. Please select or please type it and enter it. There should be multiple Windows 2019 Server AMI images should populate here. Please select the base one, the first one. Okay, so these are the multiple instance types, but in our scenario, we're going to go for T2A medium. So these are the VPCs and memory. T3. This is the instance type we're going to select here in our scenario. Please go ahead and configure the instance details on the right side corner. Okay, here we're going to give all the required information in order to launch this RDP server, where we're going to provide all the VPC information, the subnet, the public IPs, and the IAM role which we have created, and also the script which has been provided as part of the document. So as you created by your name, please select that VPC and make sure that the subnet is public. Please auto assign the public IP. Yeah. And below you can see the advanced options here. Here you need to, I can take you to the guide here. Please copy the script as per the guide. Please copy and paste it here. The next step would be to add the storage. Yeah. So by default, you already have the storage assigned to this. Not assigned, basically, it's mentioned here. So we're going to go with the default. Again, this can be customized as per your requirements. Next would be the add a tag. So add a tag, you can give a name. Just mention any name and you can have it mention as RDP server. The next step would be to assign a security group. Yeah, so we have to create a new security group. You can name it. I would try to make a you can go with the document. I'm going to put my initials here. Yeah. As you can see, there is a this security group mentioned as 00. This should allow us to communicate with our HANA database or any other server within the network back and forth. So once you make sure that all the details are entered, please go ahead and go for the review and launch. That's okay. Make sure that all the information is accurate, whatever you want to have it. Go ahead and launch the server. As we have created the key pair earlier, just provide that information. Yep.
Just check if you have assigned that public IP on the first screen. So when you review it, you can see that.
Okay, sure.
You can check under the instance details, yes.
This is the place.
Yeah, so you have disable. I think you need to
Enable
select
it. Yeah, sure.
enable. Yeah.
Click on previous step.
Yeah. Thank you. That. Yeah.
Auto send public IP.
Yeah. One second. Yeah. Enable, right? Okay. Are we good, Kiran?
Yeah.
Yeah. Go to review and launch. Yeah, make sure all the information is accurate so that you don't face any issues going further. Yeah, thank you. Please acknowledge and launch the instances. Just to monitor the progress of the instance launch, view on the instances on the right side corner. It has been it's initializing and it's initiated. Once it's ready, then we're gonna go ahead and create the password and try to connect to the RDP server. Yeah, It's still running, it's trying to create. It required another couple of minutes. In the meantime, anyone has any questions or any delays? Do you have any issues? Let's try once again. Let's give it a try. Yeah. Yeah. Please give it the prompt key here. Yeah. Once you decrypt, it should populate a password. Just keep copy and paste it aside. And in your notepad. Yeah, you can the better way is to download the remote desktop file. This should automatically connect you. Please provide the password here. There you go. You are into the RDP server now. Once in the second lab, once we launch the HANA database, the quick start, you should be able to access that HANA database. So we have a file where we're going to install here the HANA Studio, and you're going to access the HANA database through this file. Also, as a last step, you can also log in the PowerShell. Just check for the Java version. Make sure the Java is available. Yeah. So we are pretty much done with the lab one. I'll wait for a couple of minutes until we go for a break. If any issues, we're gonna fix, or else after the session is done, in the end, we're gonna have another half an hour just in case if anyone has any doubts, we can clarify them. So team, can we break for 10 minutes and come back with the module 2?
Sure, Vikram.
Yes, we can.
Yeah.
Attendees, kindly please take a small break, and we'll come back in a few minutes to resume the next level in the sessions. Thank you.
So we're coming back at 10:45 Central, right?
Yes, yeah. We have 5 minutes of delay, but I think, yeah, we can accommodate that. So we will be back by, yeah, in 15 minutes, yeah, 10 minutes rather. Yeah. Hey team, I'm back.
Hey Vikram, should we start?
Yeah, I am assuming everyone is back. So Nimisha, you want to check if the participants are back?
Yes, on it. Yes, Vikram.
Yeah, I think so. Venkat, please take over.
Sure. Can you make me the presenter?
You are Venkat.
We can see now, Venkat.
Excellent. I'll get started. Hello, everyone. Thank you for being here. First of all, my name is Venkat. I'm a senior partner solution architect with AWS. Thank you for showing interest on this topic of SAP on AWS. For the next 30 minutes or so, I will talk about the support model of SAP on AWS, what teams are responsible for what layers of SAP systems when you run them on AWS. And I'll also talk about the various architectural patterns for SAP on AWS, including high availability and disaster recovery options as well. So as we go through this session, please feel free to post any questions that you have in the chat section. We can also talk about those towards the end of the session. So I'll start with support model when you run your systems on AWS. So when you talk about hosting your SAP systems on AWS, essentially you have three layers. The primary layer, which is depicted at the bottom of this slide, is your infrastructure layer, where you host your racks of servers, your storage, SAN, and your physical premises. So AWS manages all this aspect for you. And AWS essentially takes away the undifferentiated heavy lifting, the overhead of doing these activities from customers. That way our customers can actually focus on what is important and what is primary for them as a business. All right. And when you go to the next layer, which is your infrastructure services, and by that I mean your guest operating system, your virtual machines where you patch them, ensure you have good security in terms of firewalls, you monitor those VMs, etc. So this falls under the purview of customer. And if a partner is engaged by the customer, your partner team would manage this layer. And then comes your SAP application layer, where typically your SAP basis administrators kind of install your systems, operate, and monitor, upgrade your systems. So again, this is another aspect which falls under customer or partner's purview. So this is to give you a quick insight into who is responsible for what aspects when you run your SAP systems on AWS. I'll now talk about when you face an incident when running your SAP systems on AWS, how do you deal with that incident workflow, right? So this is largely similar to what you see when you have your systems on premises, which means when you encounter an incident, your teams, search, will log on to your service marketplace or SAP portal and search for a solution for the incident. And then they go on to create an SAP incident. So this is when your SAP support team comes into picture. So they triage the incident, and based on their findings, if the issue is related to the application, they would probably change the processor to your development team or SAP development team. And if they find that the issue is related to infrastructure that is provisioned by AWS, the incident is assigned to an appropriate processing group within the SAP incident. Alternatively, you can also engage AWS support directly. So just to let you know, in order to run your production SAP systems, you need to mandatorily subscribe for AWS business support or enterprise support plans. So leveraging these support plans, you can engage AWS support directly so that they get onto the issue or troubleshoot and resolve your problem and get back to you with the resolutions. So that is how your typical workflow works for incidents when you run your SAP systems on AWS. Now, another mandatory aspect from a technical point of view is AWS data provider. Arun touched on this briefly. So essentially, AWS data provider is a daemon or a service that runs on your EC2 instances. And this collects a lot of information about your instance type, instance ID. It also collects other system configuration information such as your main memory, number of processes, and various other aspects. And it makes this information available to your SAP platform or SAP systems via SAP OS collector. And once this information is available in your SAP system, this can be used by the support teams to troubleshoot any issues, analyze the trends of utilization, etc. So this is a mandatory component again to run your production workloads, especially SAP production workloads on AWS. Now let us look at the architectural patterns of SAP systems on AWS. So you have a basic architecture wherein you run your systems in a single availability zone. Mostly you run all your components on single EC2 instance. You can separate them out too. So this is an architecture where you tend to afford larger downtimes, which mean these are suited for systems like your training and sandbox systems. And then you have your high availability systems where you leverage multiple availability zones that Arun talked about. And since these availability zones provide low latency and high bandwidth network connectivity, you can ensure that you have fault tolerant and highly available SAP systems running. And then you have disaster recovery setup. So you, again, based on the requirements of the customers, you can achieve different levels of disaster recovery for your SAP systems. So we'll dive into each of these aspects in the next slides. So the first one is your single instance architecture, the basic architecture that I was referring to. At this point, essentially, you are running your SAP system in single availability zone. And most often for systems like your training and sandbox systems, you would even run all your components such as your central instance or your additional application servers or databases all on one single instance. And the reason why you do this is to optimize cost primarily for the systems where you can afford longer downtimes, and RTO, RPO could be several hours or even that go into days. And another slightly extended version of this basic architecture is distributed instance architecture, where you're still running your instances in single availability zone, but you are separating out your SAP instances onto separate EC2 instances. So which means your ASCS would run on one EC2 instance, whereas your primary application server runs on another EC2 instance, so on and so forth. So here you are removing the EC2 instance or the VM as a single point of failure, but still you're susceptible for availability zone level issues. And that is where you would still not want to run most of your mission critical applications in this architecture unless you know that you can afford higher RTOs and RPOs. So this is also suitable for QA and training systems as well. And then we have your highly available options. When you talk about high availability for SAP systems or even in general, you measure this aspect in something called MTTR, which means your mean time to respond or mean time to recover. This is the time that you take to have your systems back up and running without having any interruptions. So you typically have two types of high availability setup. One is near HA setup, which means you kind of have your monitoring setup installed on your infrastructure, in the sense you can use Amazon CloudWatch, or you use AWS Lambda or any other monitoring scripts that you want to deploy. And this monitoring setup would alert your support teams whenever there is a failure, and your support teams would come in, kind of automate, or rather manually fail over your instances to your secondary availability zone. And because of this manual intervention that is involved, you typically take several minutes, but usually less than an hour, to recover and restore all your applications in a fully functional state. Again, when you use clustering software solutions, you achieve a true HA setup. Essentially, you have several software solutions that are available that you can use on AWS, such as SUSE High Availability Extension or Red Hat HA add-ons. And you have other independent software vendors also who provide software solutions for HA capabilities for SAP. And using these, you can fail over your SAP components automatically with minimal to no manual intervention. So this means your recovery time, or your MTTR, would be typically less than a few minutes. So this is how you achieve your high availability. So let us look at how the architecture would look like. So this is an SAP architecture where you use two availability zones. You can see a primary availability zone and a secondary availability zone. In the primary availability zone, you install your ASCS, your additional application servers, and your database. And in your secondary availability zone, at any given point, you are primarily running on your database instance, and you have your database log replication on a continuous basis. That way you have your data in sync in your secondary availability zone. Optionally, you can use active additional application servers in your secondary availability zone. So depending on the latency between the availability zones, you typically run a few additional application servers in an ongoing manner. Otherwise, you can run all of them in your primary availability zone. And in case of a failover, what's going to happen is you use Amazon machine images, and you spin up your primary application server and your additional application servers. So there is a manual activity that is involved to spin up the instances on your secondary availability zone, and that is where the MTTR is typically less than an hour, but usually several minutes. And you can incorporate certain level of automation in terms of provisioning these instances to minimize the time to recover. And then the next option is extension of the previous one, where you use your automated failover software solutions like Red Hat or SUSE solutions that I have talked about. You have your ASCS and your NQ replication server in this cluster. So your ASCS is running in your primary availability zone, and your your ERS is running in your secondary availability zone. And both these are in a pacemaker cluster, where you have your NQ replication, but also in case of a failure, the cluster software would automatically fail over this component to a secondary availability zone. And your database anyway is set up for log replication. That means your database is up and running and is in sync with your primary database. Again, you use AMIs to provision any additional application servers. So this way you have a robust HA setup, and your recovery time, your mean time to recover, is very minimal because of the automation that is involved here. And from a network perspective, you use something called overlay IP for your highly available components. And this overlay IP is typically outside your VPC. This is to ensure that even when your an AZ fails, you still have access to this IP address. And that is why we use this overlay IP outside the VPC. And because this is outside the VPC, you cannot access this IP directly. So you would need to use an elastic load balancer that is depicted here in this architecture. And this elastic load balancer points to the overlay IP, which again in turn points to any the active component, be it in the primary AZ or in the secondary AZ. So that way you are achieving highly available setup, which protects you from even availability zone failures. I hope you're all following. Please, again, feel free to post any questions. We can look at those towards the end of the session. So now I'll talk about disaster recovery strategies. So while there are several disaster recovery strategies that you can employ, I'll touch upon those which are relevant to SAP solutions. So first one is a passive DR, where you kind of leverage two different regions, and you primarily rely on your backup and restore methodology, where you back up your database, you back up your instances in the form of AMIs, and then replicate this data or these backups into the secondary region. And then in case of a DR, use those replicated backups and restore your instances and databases. Typically here the RTO and RPO are higher because you're not having fully provisioned and fully available instances running in your secondary region all the time. But the main advantage of this is your cost for this setup is very low. And then you have your pilot light DR. So this is where you typically run only your critical core components in your secondary AZ, while all your primary components are running in your primary AZ. And like for example, your database, you run a database in your secondary AZ, which is in sync and getting replicated from your primary AZ. So this way, the number of systems that you want to bring up at the time of disaster is less, and accordingly your RTO and RPO is also less. So this is slightly costlier than passive DR because you are always having your database up and running, but then you are minimizing your RTO and RPO also. And then you have your warm standby DR. This is again an extension to pilot DR, where you have more number of components, though only critical components, but more of them would be always up and running. This way, you have very minimal number of SAP systems or EC2 instances that you want to bring up at the time of disaster. And because these are always up and running in the secondary region, your cost is slightly higher. In fact, your cost is highest among the three options with the warm standby, but your RPO and your RTO is in the matter of seconds. So your RTO and RPO is minimal in this kind of a setup. So let's look into each of these architectures here. So as you can see on the towards the left hand side, you have your primary region, in which you have a highly available setup that is implemented for your SAP systems. You have two availability zones. You have your primary AZ, where all your primary systems are running, and your secondary AZ, where all your secondary systems would be running in case of a HA situation. And then you have your secondary region on the right hand side. And in this region, as you can see, all your ASCS or AAS, which is additional application server, or your database are grayed out. This is to demonstrate that these are not active at all times. You essentially use your AMIs, which are stored either on your EFS or on S3, and you set up a cross-region replication for your S3. And in case of EFS, you use data sync, EFS sync, to replicate your data or content from your primary to your secondary regions. And you use these data that is backed up into S3 or EFS. When I say data, it could be database backups, or it could be AMIs. And you use these to provision your EC2 instances. And you use this backup also to recover your database. So this is kind of a manual process, which is kind of passive DR that we call. And because of the manual effort and the activities that are involved at the time of disaster declaration, you typically have longer RTOs and RPOs, but then your cost for this would be minimal because you do not have all your systems running at all the times in secondary region. And then similarly, when we talk about pilot light disaster recovery for HA architecture, this is an extension again of your passive DR, where as you can see, you have your database system or instance running. You can have your database as a smaller instance compared to your primary region, and all you do is have your logs replicated at real time asynchronously. And at the time of disaster, you can resize your database and bring it up. You also have your ASCS instance running, but your additional application servers or your primary application servers would be provisioned at the time of a disaster, and your entire SAP system would be brought up at that time. So again, you would use cross-region S3 replication, and for EFS you would use cross-region replication again, so that you leverage the AMIs and the backups or any other content from your primary region to be accessed in your secondary region. And this is fully or a full-blown disaster recovery setup, also termed as warm standby, wherein you, as you can see in your secondary region, you have all your components running. You can see all of them are active or depicted as active here in this picture, where your database is being replicated. You have your ASCS, even you have your PAS and additional application servers. So this way, when a disaster is declared, you would not need to really provision any instances, or you would not need to use any backups and restore. All you would need to do is recover your database and bring up your SAP systems, and you're good to go. And include your automations. This one has RTO of less than a minute, or in that time range. So essentially, this gives you the most protection, highest or rather the lowest RTO and RPO, while your cost is slightly higher. So it's kind of a trade-off between your cost and your RTO requirements. So this is how you kind of deploy your SAP systems in a highly available manner, and also have your disaster recovery setup implemented for SAP systems, so that you are fully protected against any failures. So this is all that I have to cover today. If you have any questions, please feel free to post them in the chat. We'll be more than happy to answer your questions. I do not see any questions here. So then I would probably, hand it over to Srinath, who will talk about HANA deployment options. He will also talk about what are the various benefits that AWS offers in terms of deploying your HANA databases on AWS. So Srinath, over to you.
Thanks, Venkat. All right, can someone confirm that you are able to see my screen?
Yes, we do, Srinath.
Got it. Thank you so much. I want to start my presentation by thanking everyone to give us the opportunity to talk about SAP on AWS, and why 5,000 plus SAP customers are on AWS. Like why would so many customers choose AWS, and what is the what are the compelling reasons behind it? So my presentation is going to be focusing mainly on SAP HANA and various architecture patterns and various options on achieving high availability disaster recovery for mission critical SAP systems. So before I start the presentation, I want to request the participants to send questions so that my colleagues would be happy to answer them on the chat. So feel free to send any question that you have. You don't need to restrict it to HANA or anything like that. You can ask any question that you have when it comes to SAP on AWS. We would be happy to provide you the answers. Okay, let me move to the next screen. I already gave my introduction, and a quick introduction about me is like I'm a partner solution architect at AWS focusing on SAP workloads, and my primary responsibility is to help partners and customers to bring their SAP workloads to AWS with the best practices that SAP has in running these mission critical workloads. Let me start with talking about what differentiates Amazon Web Services from other cloud providers, or how do we support these HANA workloads on AWS platform. So if you look at HANA database, SAP's strategy is aligned with SAP HANA, which is an in-memory database, and they have published the sunset or end of life support for other databases that are out there in the market. So SAP is primarily focused on developing their SAP application on SAP HANA database and then delivering new innovations primarily based on this HANA database. And we are seeing huge adoption from the customers and partners on HANA side. So if you remember, Arun has covered about SAP and AWS journey, and then where we were the pioneers in launching these native high memory instances. I will go little deeper into it, and if you need any information, feel free to send us the questions, and then we will circle back with you and understand your use case and then provide you the required information. We have up to 24 terabyte SAP certified instance. These in-memory instances can scale up or scale out. Scale up is like where you grow vertically, while scale out is horizontally. We have 24 terabyte single instance, which we call as bare metal instances, which support up to 24 terabyte running in one instance, right? So that is the highest memory that is certified by SAP. And since these are in-memory instances, they do need to go through a detailed certification process from SAP. Once SAP certifies, then only they should be used by our customers for their production workload. So that's a support terms and condition that SAP has laid out. So our instances are certified by SAP, and they are native to AWS. And when I say native to AWS, they are not co-location based. These are not something that we ship out to the nearest location that you have, where you set it up and then create connectivity between them. Instead, they are based out of our availability zone. And when we say our availability zone, it leverages the global infrastructure that we have. Imagine if these are co-location based, there will be so many parameters that interfere with the latency and providing you the newer innovations that are available on our global infrastructure, right? So since these are native to AWS, you do not need to worry about having a co-location or get into the restrictions that come with those co-location. We provide simple management-based UIs, and as you may have been familiar by now from your labs, we have a refined, simple user interface where we provide both commands and graphical user interface support to access these instances. And we do offer flexibility to scale these instances depending on your business needs. I spoke a little bit about scale up and scale out, and this one emphasizes on various options that we have when you have scale up and scale out requirements. By scaling up, if you are growing vertically, like you want to run it on one instance and your workload fits into the memory that is offered by us, and we offer various categories, and you have the flexibility to choose depending on the size of your instance. And I want to call out that you can lean on to our partner YASH Technologies if you have any questions about choosing these, and they have the required experience, and then they would be happy to assist you and then pick you the right instance size, because that is very important to have a successful and a optimized SAP instance on AWS. And when it comes to scale out, this is where you can run multi-node and you can grow up to 100 terabyte. So scale out is primarily beneficial for OLAP based workloads, which are like BW, or if you have a data mart. S/4HANA does support scale out, while Suite on HANA is not supported with scale out. That's a restriction from SAP. Like, they do not have the required application logic to support HANA scale out with Suite on HANA. But with S/4HANA, you can leverage this option, which can provide you up to 48 terabyte instances. And we will work with you to help you on picking up the right instance for your workload with the HANA journey.
Srinath, 1 second.
Yeah.
There is a small update. The participants can unmute themselves if at all they want to ask any questions. They can ask, and as well as they can put it in the chat. So it's a small update. Everyone, you can unmute yourself and you can go ahead and ask questions. You can whenever you want.
Good call, Vikram. Yeah, feel free to talk. I know we would be happy to talk to you, rather than typing. So feel free to unmute and ask any questions that you may have. I want to quickly call out that SAP Business One is fully supported on AWS platform, and you can run this Business One either on SQL Server database or SAP HANA. And I have listed the instances that are certified to run SAP Business One on HANA. As some of you know, like, Business One is mainly intended on running small to medium enterprises whose footprint is smaller, and then they really do not need the bigger instances. So that is something that is available on AWS platform and fully supported. I want to quickly touch base about the deployment models with respect to HANA database. My colleague Venkat has walked you through various architecture patterns when it comes to SAP application in general, while in this, the scope is strictly limited to HANA database. We do support similar patterns. If you recall the SAP application patterns, you pretty much have the similar patterns available on HANA database. This all goes back to your business continuity requirements and the type of response times, or like the recovery time objective and response time objective that you have. Based on that, we work backwards and then help you in choosing the right deployment that works for you. Single node deployment is where you are using one availability zone. It's again like where you do not have that, you are not spreading out across the availability zones. Your workload is restricted to one availability zone. With multi-node deployment, you have multiple nodes running in single availability zone. You are spreading your workload, but again, you are within one availability zone. And the other one is like cross availability zone, high availability deployment. So this is where you get the additional features that if the loss of one availability zone, you would still be able to function. As we explained in the previous sessions, our availability zones are discrete, distinctive data centers. That's how you can view them as. They're running on isolated power network that is different from each other, and they are separated by certain distance, like at least 50 kilometers to 80 kilometers is how we plan these availability zones. And they have dedicated high bandwidth, low latency network among them, which helps you to provide that sub millisecond latency between the availability zones. Okay, now I want to give you a little overview about why or what is AWS commitment with respect to SAP. What kind of automation tools that you have? We Automation is one thing that we hear a lot of good feedback from our customers, because automation helps you to tap into various repeatable mechanisms that are available, that AWS is innovating on behalf of our customers. And by doing this, AWS is doing all the heavy lifting when it comes to networking, infrastructure layout, and various other SAP application related backend, like the core compute, storage, and network that are required to run these SAP applications. And by providing you these frameworks, AWS is taking care of all the heavy work, while you as a customer can focus on configuring your application, designing or building new applications on top of this, so that you can provide more value to your business users. On those lines, we have two great products, which is like HANA Quick Starts, and another is Launch Wizard for SAP. Quick Start is our cloud formation based templates that we launched about 6 to 7 years ago, and where we have given guidance, and we released the code that this is a template based service that's available on our AWS marketplace or AWS platform, where you can go and then quickly deploy HANA instances by following the predefined cloud formation templates, which takes care of it takes care of creating either you can choose to create VPC, or you can you can choose an existing VPC to launch your instances. But it takes care of creating your EC2 instances. It creates the volumes, and it also creates the required security groups. And also you can install SAP HANA. And and one of the coolest thing that I personally liked with these tools is like it follows the best practices that we have heard from our customers, are the problems that they have gone through, and then we embedded those learnings into this automation, so that you are not starting from zero. Rather, you are building your application on the feedback or on the experience or on the best practices that are defined for SAP. So Launch Wizard for SAP is our newest innovation, which was released like last year, I think mid of last year, and we are constantly doing many iterations with this. This is a wizard-based tool which helps you to pick the SAP certified instances. Like it gives you the recommendation, so that you do not need to, because there are so many instances available on Amazon EC2 platform. Like we have so many instances, like Arun has shared with you, depending on the type of workload. This Launch Wizard service will help you to list SAP certified instances, so that the error or any human error is taken out, and you do not need to get into any trouble by spinning up unsupported instances. So I have come across some experience where some customers unknowingly picked up an instance that is not supported, and then later realized that, oh, okay, they should have picked a different instance. So based on that learning, we included those learnings that the customer went through, and then made it easy for our customers, where they are able to pick the right instances. And and some of the other features is like you can reuse infrastructure settings, you can perform any SAP specific configurations, because we provide you pre SAP launch wizard script, like where you can input a script which can be run before launching the SAP instances and after launching the instances. So this will help you to customize depending on your use cases. And then it also gives you cost estimate depending on by using on-demand model, so that you have an idea like how much cost it's going to incur, so that you can plan it accordingly. And it gives you a central place to view SAP deployments, and it integrates with systems manager and then CloudWatch logs, so that you are not missing out, or you don't need to manually configure any of these services that are available. Here is a quick diagram that represents what Launch Wizard does, and then if you compare it with on-premises, the left-hand side talks about on-premises, while on the right-hand side you have on AWS platform. if you look at it traditionally, you need hardware, and then on top of your hardware, you need your operating system and storage allocation, and then you need to configure your server and storage. Since SAP is a complex application, there are certain set of libraries that are required before you proceed with the SAP software installation. And then your basis team or application team comes and then does the SAP install, and then there are application specific configuration. By using this automation tool, Launch Wizard is going to take care of spinning up your hardware or deploying your EC2 instances, and it can also attach the EBS volumes that are required depending on the application. Those are all pre-populated depending on the size of HANA database that you pick up. For example, if you are going with like 512 GB RAM, then we recommend you to use 225 GB EBS volumes and then stripe them for maximum throughput. This is a learning that, or this is the type of automation that we are giving with our Launch Wizard, so that you don't need to manually figure them out and then do those steps manually for you, which is both time consuming and which requires a lot of expertise. Yeah, and one point that I want to call out is like AWS Launch Wizard does support all the three types of configurations that I discussed, which is like standard, high availability, standard, distributed, and high availability. With high availability, you can leverage SUSE and Red Hat based pacemaker. And if there are basis folks on this call, if you remember, or maybe it is still the case, if it is on premises and if you want to set up high availability, it is a very big task where you need to sit with your infrastructure teams, you need to sit with your operating system teams, and then identify how you want to configure the high availability and what packages you need to install. I mean, it's going to be like a couple of weeks of process, right? With Launch Wizard, you can achieve that in 2 hours. That's the type of advantage you get on AWS platform with respect to SAP. Let me focus now on SAP HANA high availability situations, and then depending on the use case, again, there are metrics that I have included on this slides, where you can, the key metrics here is going to be your RPO, RTO, and cost. Depending on that and depending on your use case, you can pick one of these architectures. But I just want to introduce you to the architectures that are supported on the AWS platform with respect to SAP HANA database. So this one talks about achieving high availability using backup and restore methodology, and the recovery point objective is going to be medium, recovery time is going to be more, and the cost is going to be low. Why the recovery time is going to be high is like, if you look at the architecture, what I am doing is like, I have my primary running in availability zone A. I mean, I'm using the same region to achieve the high availability. I'm not running any standby instance, or I'm not running any hot standby instance here, right? What I'm doing is like, I'm taking periodic snapshots of my primary database and sending it to Amazon S3 bucket. Amazon S3 is an object storage that we provide you, where you can use it. You can access these buckets within the regions. And once you send that backup to Amazon S3 bucket, those backups are available to you on the other availability zones. So when you have an issue, or when you lose your availability zone A, then you will have to manually start, or you can you don't necessarily need to manually do, but you can automate some portion of it. But however, still there is going to be manual intervention on initiating these type of things. So what you are doing is like, you are using the backup that has gone to the the Amazon S3 bucket, and then you are restoring that onto the second availability zone. So that is the reason recovery time is going to be high in this architecture, but the cost is going to be low. The reason is like, I mean, you are not consuming anything outside of running your primary SAP HANA database. All you are doing is like, you are sending your backups to S3. You anyway need your backups to achieve your business continuity. So this is going to be one of the lowest cost. But again, the key point I want to call out here is like, all this will evolve based on your use case and requirement. Now I'm going to talk about how you can achieve higher availability, which is like either by using standby or where you can, where if your RTO and RPO are aggressive, how you are going to do that. And this one talks about HSR, which is HANA System Replication, which is a technology that is provided by the vendor SAP themselves. This is fully supported by SAP. So you wouldn't run into any of the supportability requirements or supportability issues, since this is a native database technology that comes with HANA database. And then there are some innovative options that we would like to showcase to you, where you can run it on leaner instance, like instead of matching the same size as your primary HANA database, you can run with smaller instances and leverage or reduce your recovery time objective. So first option is like achieving high availability using smaller standby instance with preload off. What this means is you have a primary instance running on availability zone A. On the availability zone B, you are going to run a smaller instance over there with preload off, so that you are not actively running or you are not loading all the content into your memory. Since the instance size is small, you are saving on your instance cost. But however, this is still, there will be active costs that you will incur to achieve this high availability. So if you look at our key parameters, RPO is going to be low because we are leveraging HANA System Replication, which constantly sends the changes on primary database to the secondary database. So that is the reason, like your RPO is going to be low, and your RTO is going to be medium, because whenever you have an issue with the primary, you will need to scale up your instance on the availability zone B, because to keep the cost low, we are not running the standby instance at the same size as primary instance. And if you remember, this is one of the key features that the cloud, that AWS platform offers you. It is very easy and quick for you to scale up or scale down your instances. You do not need to give, or you do not need to oversize your compute, because with the click of a button, you can get the compute that you need, or you can change your instance sizes. Moving on to the next architecture, this is where you can run HA using shared non-prod instance with preload off. And what it means is you are matching your primary instance with the same amount of compute that you have on the primary, but you are running it with preload off and leveraging that for running your development and QA. And the advantages of this architecture is you are not keeping your standby hardware or standby compute idle. You are repurposing it for development and QA. That is the reason, like you will have your cost will be offset, though it shows like cost is high. That is from the perspective of HA. But however, the high cost of running secondary instance is offset by co-hosting your development and quality workloads. But what is the trade-off here? The trade-off here is like whenever you lose your primary instance, you will need to shut down your development and quality and scale up the standby instance so that you can resume your production operations. This may be a architecture that may work for some customers who have higher or who can accept high RTO or RPO. But again, that is an option that our customers can certainly think about depending on the use case. Okay, this is one of the popular options that I see with many customers. The reason is like when they have mission critical workload, they really do not mind incurring that extra cost to achieve the high availability. And this is a full standby. You are not trading off any of your compute, or you're not undersizing it or anything like that. You always have your standby same as your primary, depending on your HANA System Replication settings. Like if you use synchronous in memory, which means like it constantly keeps updating your secondary database with all the changes that are happening on the primary. And if we look at our RPO and cost, your RPO is going to be low because you are using HANA system replication where you can configure it depending on the business needs, and your RTO is going to be low because you already have a standby instance. You don't need to scale up, or you don't need to do any extra steps on that. So the cost is going to be high because you are actively running a standby instance to match your primary instance. I do want to call out here that to automate this failover, there are third-party clustering solutions, which I'm going to give you a quick preview in one of the slides that's coming in my presentation. Now I want to talk about DR, which is a disaster recovery. We spoke about HA. I mean, there are some customers like who really wants to make sure that they have a comprehensive DR solution. So for the DR, we have multiple options as well. So where you can set up a leaner or a small compute on secondary region. So if you look at my architecture diagram, I have mentioned the two regions. Your region 1 is where you have your production SAP HANA database is running with high availability setup, which is like it's using availability zone 1 and 2. Now I need to architect it in such a way that with the loss of region 1, you do not lose your operations completely, and it's going to be a very rare event. Losing a region is not a small event unless there is a very big major event like a meteoroid coming and hitting somebody or some city, which we don't want to happen anyway. So in that case, you can have a smaller compute or smaller instance on region 2, and then you can rely on system replication with a synchronous mode to replicate the changes onto that region. So here again, you have the similar options. You can run it with preload option, or you can run it with full memory running it. If you look at key parameters, your RPO is going to be low, your RTO is going to be medium because you are not running it with the same instance size as your primary. You are going to probably run it with smaller instance, and when there is a disaster recovery declared, depending on your business continuity requirements and the DR instructions that are available within your organization, you can scale up accordingly. And the cost is going to be high because you will need to start consuming some of the resources on your DR environment. You can reduce the cost by by mixing and matching some of the options that I mentioned now, like you can rely on backup and restore, but again your RTO is going to be high because like you need to create the compute, you need to create your storage and everything else, and then perform a restore. Depending on your HANA database size, restore is going to take time, right? I mean, if it's going to be a very big database. Okay, one more option, just like I spoke about it earlier. So to keep the cost low, you can rely on that backup and restore, where you are you're not actively running anything, you are launching them on demand. So this is one of the great features or great advantages I communicate to my customers, right? Because you do not need to commit, you do not need to purchase your hardware, because when you are on AWS, we provide you this compute storage network on demand. All you got to do is like probably just few clicks, and then you can try out, and it's all available to you on demand. You don't need to give any long-term commitments. You can even try it, like if you have a requirement where you need to do a DR exercise to make sure that you are compliant to your audits and other stuff, so you can purchase this compute memory and other stuff like for 1 or 2 days, and then you can prepare your environment, and then write down the times, and then execute your DR test, and then be compliant with your audit requirements, so that you do have business continuity when there is a big disaster. So this is one thing that I see customers like who run at on-premises. They I mean, almost every customers and other organizations that I worked, that will always be a huge challenge because there is because of the logistics that's involved. So this is one thing, one bigger advantage that comes to bigger organizations or the customers that who really wants to have a working DR that can be tested frequently. Okay. This is going to be my last slide with the content where I wanted to talk to you quickly about HA partners that are available. AWS has a huge ecosystem. So we have a huge amount of partners who are developing solutions for our SAP customers on AWS platform. So if you look at SUSE, Red Hat, Veritas, CEOs, and all these customers, they have the cluster failover solutions that are available on AWS platform. So it will be a great benefit to our customers who come to AWS platform to leverage these solutions. And because we have more than 5,000 customers on AWS platform, you get the advantage of all the learnings, all the experience that we have by having these customers. These are some of the key ISV vendors that are doing cluster software or providing cluster solutions. And one point I want to call out is like SAP does not provide any specific cluster guides for the implementation of clusters. So it is always provided by the operating system or the vendors that are responsible for the OS layer, and we can certainly help you. So if you have any questions on HA or anything like that, please reach out to our partner YASH and us. We would be happy to talk to you one-on-one and then look into your use case and offer you architectural guidance. That concludes my presentation. Thank you so much for the opportunity. Please feel free to post your questions. We will be happy to answer you and help you in your journey with SAP on AWS. Thank you.
Thank you, Srinath.
Yeah.
So we'll be proceeding towards the lab 2. So team, I'll give a quick walkthrough for the lab 1 with what we have done and how that can be helpful for the lab 2 and what kind of activities we're going to achieve in the lab 2. I'm going to just give a brief walkthrough. Nimsha, can you please give me the access to share my screen? Thank you. Team, please let me know when you can see my screen.
We can.
So this will be a more interactive session. I think we have unmuted you, so you can stop me whenever, if I'm fast, you can stop me if you're finding any issues and ask for questions. If you're stuck anywhere, we can resolve it. So as part of Lab 1, as you have seen, we have created a VPC, we have created an IAM role and the key pair, and we have launched the RDP instance. This is the RDP instance where we're going to connect to our HANA database, which we're going to do as part of the Lab 2. So coming to the Lab 2 here, what are we going to achieve here? As Srinath mentioned, it is more of a templarized version where everything is automated. For Lab 2 here. Yeah. Okay, deploy SAP HANA. So this is a quick start what Srinath was mentioning, which is a templatized version where we're going to install HANA with the template, which is automated. And once the HANA database, like these are the information we're going to provide as part of this template, where we're going to give the existing VPC, which we have created as part of our Lab 1. And this is the information what we're going to provide here. This is all, in fact, coded in here. But when you're going to launch, as per your requirement, you're going to have it changed accordingly. As I mentioned in the earlier also, the IP range can be applicable as per your network settings or network requirements. So, and we're going to give the HANA instance type. These are the certified instance type, or which are from AWS standpoint, which also Srinath has mentioned. So we're going to choose the certified SUSE Linux, the OS, and the instance type. by choosing this, you don't have to worry about whether you are choosing a right one or wrong one. Okay, and the right EFS volume we're going to select here, and coming down here. So as part of this template, generally what happens is we don't get the we only be able to download the software. The HANA software is depending upon the license what you acquire. So we're going to download the HANA database dump and put it in the S3 bucket location. In this scenario, we've already downloaded and placed in this location. So we're going to give this reference as part of our creation of HANA database. So then once the stack is created, then we'll go back to the RDP server where we have created in lab 1, where we're going to deploy the HANA Studio, and we're going to connect to the HANA database and see how it, whether to make sure that the HANA instance is up and running. So now we directly go into the session to build the HANA database. So as you can see, the first screen where we talk the HANA Quick Start, just click on this link and copy the link. Yeah. So team, if I'm fast, please stop me. If you're able to access this, if you have any issues, please put it in the chat, or you can stop me and ask. So down you go, how to deploy. Please go and click on how to deploy. Okay. As we have already created the VPC earlier in the lab 1, please use the existing VPC. This should open up a different window. So create a stack. The template is already ready, and Amazon S3 URLs are also been kind of encoded here, so you don't have to change anything. Please click on next. Okay, so here you are going to provide the information, the VPC information which we have already created as part of our earlier session. So this is the VPC we have created with your initials. So choose a private subnet, and here you're going to choose the public subnet. The CIDR block, we're going to leave it as is default. This can be changed as per your requirement. Coming to the HANA. So the
Vikram, for the public CIDR, make it same as your the public subnet that you have selected. That is 10.0.0 instead of 2.
Yeah, you got it. Yeah. Yeah, perfect. Yeah, coming to the SUSE Linux, we're gonna choose the SUSE Linux, the SPS one, the SUSE Linux 15. And this is the instance type, which is already by default selected. The EFS has to be no. As you know, there is a restrictions on that. Okay, this is the place where we're going to give the information where the HANA dump has been placed. This is the S3 bucket information. So you should be having that information in the page 32 in your manual. Please copy that and paste it over here. Okay, and yeah. So as the RDP is already installed, we don't need to create another one. That's the reason there is a no option here. Yeah, and the next would be going to the next option. So team, I'll wait for 30 seconds and see if you are able to achieve or enter what all the information is required. If you are having any issues, you can call out. So I'm going to walk through once again. We have provided the created VPC. We have provided the information related to private subnet and public subnet. We have changed the decider block and made it 00 here, which we have created as part of that. We have given the right OS type here, the instance 00, the SID.
Vikram, you need to provide password.
Yeah. Oh, yeah. Yeah. So let's go ahead and click on next. You can tag it if you want, or else you can directly go on to the next window. Okay, this is the information review tab, where you have to make sure that all the required information has been provided. Okay, and you can go ahead and create the stack.
Click on I acknowledge.
Yeah, right. Okay, you can go ahead and check the stack is getting built. This will take a while, at least 10 to 15 minutes. So in the meantime, while this is getting created, we'll go and deploy the HANA Studio in the RDP server. Go back. Let me go back and check. Arun, can you check if there is an issue with the?
Yeah, let me just look into it.
I think it should be one dot, right?
No. The public acceptance with private is good.
So Vikram, looks like it failed for the parameter validation. So maybe you entered some wrong parameters.
Yeah, let me check. Let me recheck.
Please change the name of it because you're relaunching it, right? just add something. Yeah.
Okay.
So I was talking on mute. I think you have provided somewhere home as the key name.
Oh, let me check. Okay. So that was recorrected now. Shouldn't be a
Okay.
problem. This is the key pair was not mentioned probably. That's right.
Yeah. Yeah. In the last one, I think you selected home, and that's where it got wrong somewhere.
And also, can you select EFS? No.
EFS
Yeah.
is also no.
Up. Yeah. The top. Yeah.
Yeah. Yeah. I think we're good now.
You can go for a larger. That's a very small instance. It will not be able to install HANA. Okay, my bad. It was correct. It's fine. It's fine.
Acknowledge.
Yeah. So team, are you facing any issues? Or are you good? Whoever's trying to launch the HANA database? Yeah, I think the creation is in progress. It shouldn't be a problem. This will take a while, as I explained earlier. And the next step would be we'll go ahead and work on this HANA Studio deployment. So Arun, can we provide this deploy file to team?
Yeah, I think you can. I mean, I believe if there is some option to share file, you can share it.
So Nimisha, do we have option to share? So team, why I'm trying to tell you? Yeah.
No. So Nimsha is sending the code in an email, so they can just copy it and paste.
Yeah. So team, as you see, I'll walk you through that steps here. You want to install the HANA database, HANA Studio installation. There is a script which needs to be run through the PowerShell, and for that we need to create a deploy file. As you see there, we have to create this. We have to enter the script in a file, and we have to run that through the PowerShell. So I think Nimisha is going to send you the script in an email, or maybe you can do that activity as well, where you have to open a PowerShell and copy the script and name it as deploy, and we have to run that script. As part of that, we have already created that script here.
Hi guys, I have sent the script to all of you. Please check your email.
Click on this file, Control V. And go and save as. You can do this one this way as well. Yeah. Once it is saved here, right click on it, run with PowerShell. So this will download the Eclipse. In the meantime, we'll check the progress on a database. The HANA database is getting created here. Still in progress. It will take another 10 minutes at least. So yeah, so Eclipse is created, and now we're going to install the. It should create another file here. Install SAP HANA Studio. We need to run this through the PowerShell as well for it to install the HANA Studio. Quick check. Click on Eclipse. We'll see whether the required add-on has been added to the Eclipse for us to run the HANA Studio. You might need to run once again if at all the add-on doesn't appear here. You can run once more and check. Yeah, it's not, it doesn't appear. Let's run this once again. Yeah, I'm sure it should appear now.
Close that one. It's already running.
Yeah, got it.
It's already running in the. So you can close it. Yeah.
Let me close this too. Thank you. So team, are you able to get to where we are supposed to? Are you having any issues accessing? Yeah, now you can see HANA Administration Console. Click on that. Open. No, please say no. Master. So you don't need, we already created one. So here you have an option to
Click on that administration button. Yeah, below.
Yeah.
No,
Yeah.
no.
Once again.
You can just close it and open it once again.
Yeah. I'm assuming this should be ready for us to connect.
Click on the last button, Vikram. Last button. Yeah.
Yeah, perfect. So we'll add the system here. Yeah. So in order to get the host name, please go here on the instance type. Please copy this IP. The instance would be 00 default. It's a multi-container where system database. Click on next. The username would be system by default. And put in your password which you have created as part of the HANA.
So Vikram, it's not yet installed the HANA, so
yeah, I'm waiting. I'm gonna
yeah.
check. I'm gonna check. I know it will prompt. It will give an error if it is not. It's not reachable. So we'll wait for this to be done. I'm sure it will take another 5 minutes. Generally, it should be done in like 15-20 minutes.
So right now it has just provisioned the file systems. So I think the next step would be it will be start the installation of HANA.
Yeah. So team, I think we can take a break here, and once we come back, by that time, I think HANA database will be installed, and we can directly connect to the HANA and see how it looks like. In the meantime, if you have any questions, if you are stuck anywhere, if you are having any issues accessing, please unmute yourself and ask for it, or you can also put it in the chat. So we'll go for a short break for 5-10 minutes, and we'll come back and resume connecting the HANA database, and we'll go into the module 4.
Sure, Vikram. Thank you. Vikram, if you want to stop sharing your screen or something. Great, thanks.
So when are we resuming?
Yeah, we'll be back in like now it's what 1:13, so we'll be back in by 1:20, another 7 to 8 minutes. Yeah.
Okay.
Just a time check because we're running late, so that's the reason I'm trying to make sure it's like 5 minutes break. Yeah. Okay, we are back.
Yeah.
Yes.
Yeah. So I'm going to just give a brief summary of what we have done till now. As part of module one, I think as part of module one, Arun has covered all the core services of SAP on AWS, and that was followed up with our hands-on introduction on SAP AWS, where we created VPC and the RDP, and all required information has been provided. And as part of module two, Venkat has covered the architectural patterns and also spoke about the SAP workloads like high availability and also the DR. And Srinath, more specifically towards HANA, he like walked through us about the multiple ways to deploy the HAs and DR. And that was followed up by the lab 2, where we by using a quick start, we launched the HANA database. As you can see, now that we are able to access the HANA database here, and the HANA system has been installed, and we can see all the services are started. By this, we'll conclude the lab 2 session. If you have any questions, please put it in the chat, or you can ask us, unmute and ask us. And as part of module 4, where Kiran is going to walk through the different way of migrating the SAP workloads onto AWS. What are the options available? What are the features available from SAP standpoint as well as the AWS standpoint? And we will also want to talk about the YASH Ascent, how we assess the customers to migrate their workloads. What are the what kind of assessment we provide in order to move these workloads to AWS. So, so I'm going to hand over to Kiran to take it forward from here. Kiran.
Yeah. Hope everyone can see my screen, right?
Yeah.
Yeah. Hey, hi all. Thank you for giving this opportunity. So in this module, we'll see how we are going to migrate our SAP workloads that are running on on-prem or any different data center somewhere, how we can migrate to an AWS cloud. So before we get into how we can migrate, let me give an overview what is an YASH Ascent framework and what are the different phases we have and what we do in each phase. So Ascent framework consists of 4 phases like assess, mobilize, and migrate and operate mode. In SS phase, what we do is generally we do a discovery workshop where we get into the details of the customer workloads that are running on-prem. We'll assess what sizes are there, are they compatible when migrating to AWS, or what are the interfaces they have. So during that we finalize what is the architecture that we are going to get in the AWS. So in the mobilize phase, we just take a copy of one of the workload and try to migrate to the AWS. During this process, we'll try to develop a migration plan. We'll know the pain points, and we'll try to fix the issues, and we document these issues in the migration plan as well. So we'll have a migration plan, and once this is done, we move to the next phase where we do the migration, actual migration of SAP workloads. We try to see how we can optimize the downtimes and how fast we can move the workloads to AWS. This is a part of the migration part. And once we have migrated all the workloads to AWS, once all the workloads are stabilized and we have no issues, then we go into the operate phase where we try to automate things like monitoring, or we talked about refreshes. We can use automated refreshes, which helps in minimizing the manual work to refresh a system test system in the landscapes or the monitorings, and we can enable this and also try to see which workloads are not using to the full capacity. We can maybe we can optimize the hardware as well. So this will reduce the cost as well. So this frameworks is something that helps our customers, YASH customers, to migrate their workloads to AWS. So this is a part of our assessment process. Coming to the so this is an overview of YASH customers, where this is some overview of some of the customers or all the globe. Everywhere. So what we have done for each customer and what technologies we used in AWS to migrate their workload to AWS. In some cases we have used backup restore, we have some cases we have used cloud endure, we have done the DR setup, etc. This is an overview. So in the next slides we'll see what are the methodologies we can use and what type of AWS services we can use when migrating SAP workloads to AWS. I hope everyone is following. So coming to the actual migration methodology. So I initially said like we have SS phase where we try to analyze the customer's workload. What is their version? Is the version is compatible with that? If your source version of software is compatible or the OS is compatible when we migrate to AWS, or how big the database size is. And next we try to see what systems are integrated to the SAP landscape. And the fourth part is like what speed we have between the AWS and the on-prem system. So based on this, we come to a conclusion. If we are not going to change the OS, we are going to use the same OS and same SAP version, and we are not going to change it, even the database as well. Then it is called as homogeneous. I'll explain in the next coming slides. In case any of this we change, then we have to use a heterogeneous migration methodology. So I'll explain in brief about these two migration process in the next coming slides. So what is the main drivers that enables the customers to migrate to AWS? The first is agility. So you can ramp up or ramp down on your any instance anytime needed. So you can if there is a lot of workload that or any high intense memory is required, we can ramp up our AWS instance, or you can ramp down when there is no load on the system, like dev system, or you are not going to use, you're going to pay as you go as methodology. So next, like we have if we have multiple data centers, we have a work where we can consolidate our data centers to a single data center in case we migrate to the AWS cloud, where we can maintain all our servers using a console from sitting from one location as well. So we do not need to have a resource everywhere in every data center. Like if we have multiple data centers, we need an IT resource at multiple data centers. In case of AWS, that we can maintain our workloads from a single point of location. So also we have data SaaS products which are readily available and which can be easily be integrated to our SAP workloads, like data lakes and IoTs. These are the important that can be easily integrated, and this can be readily used to integrate to our SAP workloads. The next is since we are migrating to AWS cloud, we are going to use only what we use. So based on our workloads, we can ramp up or ramp down, or maybe we can set up a instance that is required for a testing, and we can just have it for 1 or 2 days or maybe a week. When the testing is done, we can just shut down the system, and we do not have to pay to the unused hardware as well. So this reduces the cost as well. These are the common drivers that mainly we can think of. So when we come to SAP migration, I have said like homogeneous and heterogeneous. In case of migration, we can split it into 4 ways where we can migrate our SAP workloads to AWS. So in homogeneous migration, if our source and database source and target database are not HANA, and we are not going to change it. We can use as a backup restore method, or we can use a classical migration like export import that can be done using a software migration software provisioning tool as well. And also there are third-party tools that can be used, or we can use a AWS Cloud India tool to migrate our workloads to AWS. In case we are migrating our workload that is running on HANA and our target is also HANA, we can either use a backup restore, or you can use a tool that is inbuilt with HANA, like HANA system replication. This can be used. Coming to heterogeneous, we can divide heterogeneous migration into two parts as well, like where we are migrating any DB to any DB. In this case, we are talking about any DB that is other than HANA. So like if we are migrating from Oracle to SQL, or SQL to Oracle, etc. We use a classical migration which can be used to migrate this, or we can use third-party tools like SNP T1. That is a third-party tool that can be used. In the fourth methodology, where we are migrating our workloads from a non-HANA DB to HANA database, we can use a SAP classical migration that comes with a software provisioning tool. And also there are a couple of ways, like we can use some DMO software provisioning manager data migration option as well, and also there is another option like data migration with system boot. This can help in migrating our workloads to AWS faster way. So in the coming slides, we'll see what each of the option can be used. So in the initial stage, I said there are two ways of migrating a SAP workload: homogeneous or heterogeneous. What is homogeneous? So if our target database operating system and the SAP version are same, like if you are going to use the same version as a source and target, then it is called homogeneous migration. In this option, we have a system copy option, that is a SAP tool, or we can use a backup restore tool and other means like third-party tools which we discussed before. In case of heterogeneous, we are going to change our operating system, database, and sometimes we may also upgrade our source SAP version as well. So this is an overview of how we are going to use homogeneous migration, and what tools we'll be using at the source, and what tools you'll be using at the migration target source. And in between that, what SAP AWS services we'll be going to use to migrate the data, like a backup or export import, we are going to see. This is an overview, like where we are doing a system copy or a backup restore and on the source, and we are moving that backup or the system copy using the services like S3, storage gateway, data sync, snowball. This will explain. We'll try to see how this works in the next coming slides. And at the target, once this is copied, how we are going to build the system in the target side. So in homogeneous system copy, we have an option like taking a full backup and restoring it. So here in this case, in case our workload is on-prem and we have a AWS cloud setup, and we have a EC2 instance running in that, and there's an AWS connection or AWS VPN or AWS direct connection between these two. Then what we can do is during the cutover, what we do is generally we stop the operations on the SAP system, we stop it, and we take a full backup of the SAP system, try to copy it to the S3 bucket over a VPN or a direct connect that is very fast compared to the VPN. We try to copy the backup to the S3 bucket. From the S3 bucket, we try to restore the backup to the EC2 instance, that is the SAP instance where our actual workload is running. So in case our database size is small, we can use this methodology. So in case we have a very large database and we are not getting the throughput that can be copied over the internet, like VPN or the direct connect, we have a couple of options like AWS storage gateway, AWS data sync, and there's another snowball methodology. where you can, it's a portable device that is sent to our data center, and that can be shipped once that is copied to the once we copy the backup to the Snowball device, we can just ship it to the AWS data center. From there we can get the backup. So in the second option, like here we have seen, in the first option we have seen a full backup restore. So in the second, how we can reduce the downtime or optimize the downtime, we can use a incremental backup restore methodology. So in this case, I have given example, like we are going to do a cutover, and we are at day 11 where we build the production instance in the AWS. We have the target system ready, and we take a full backup at the source, copy to the target using S3 bucket, and then restore it onto the production instance. In the next day, we try to take a delta backup, that is an incremental backup. We try to copy to the S3 bucket and restore it to the actual backup we taken yesterday, day before. So we try to do the delta back every day until we reach the cutover day. Once we reach the final cutover outage production, so what we'll do is we'll stop the actual production operations on the source system, take a final delta backup, then copy to S3 bucket, and from there we try to we copy to the actual instance and try to restore. And once that restore is completed, and our SAP instance is up and running and on the AWS side. Coming to AWS Storage Gateway, this is an AWS service where it can be used for copying any files from a network share to S3 bucket. So here we install S3 gateway on the on-prem system, and that is connected to the gateway storage gateway service that is on AWS cloud, and that inside is connected to the S3 bucket. So once we have a backup on this NFS share, it automatically copies the backup from the network share to S3 bucket, and we do not need a manual intervention to copy it. And we can also take a backups, logs, everything on the network share, and it can be just copied to S3 bucket. It optimizes the bandwidth as well. And also once next day when we are taking another backup, it only transfers the changes that is required that happened in this day. Next day, it only transfers the changes. AWS Data Sync. This is another service that can be used to copy the data files, meta files over the from an on-prem system to our AWS cloud. So this is a tool that is similar to rsync, but it is 10 times faster than rsync or SAP tool. So here we have an agent, sync agent installed on the VMware. So that is connected to a network share where our backups or logs are stored. So once these are connected, it automatically transfers or syncs between the network share and the network share that we set up on the AWS cloud. So once this is done, the data, the replication happens between the source and the target, and our backup is ready, and the logs are also ready on the AWS side, AWS region. So this helps in building the new our target system at the AWS cloud. Coming to AWS Snow family, this is a portable device. This is used in case we have a large database size and we are not unable to transfer data over a direct connect. So what happens is, like Amazon Web Services sends us a portable device that is connected to our network, and we try to take a backup and copy it to the Snowball, and we try to then we ship it to the AWS data center. So in this Snowball device is an encrypted device. It is high class secured, and there is no issue of security. So here in this case, this can be used as a offsite backup storage, or this can be used as a disaster recovery, or this can be used as migrating our workloads to AWS. There in AWS we have a continuous data production tool that can sync the disks from on-prem to the cloud where our EC2 instances are running, and we just need to set up the cloud agents or tools like Cloud Endure, AT&T, and DoubleTake. This tool tracks the changes on the source and copy it to the target EC2 instance, and this is a faster way of copying our source system to the target on Amazon Web Services. So in continuous data production tool, we talked about Cloud Endure. So what is Cloud Endure? How does it work? So what is the advantage we have? So we have a source infrastructure, and we have a target infrastructure, like we have a cloud setup running on AWS. So what we do is we install the Cloud Endure agents on the network that are internally connected to the disks or the data files or network shares that are running on the source, and this is connected to a Cloud Endure replication server that are running on the AWS cloud. So this is a staging area where our data is copied to the AWS, and this can be monitored using the AWS Cloud Endure console, where you can see the replication, what is happening, is a sync happening, or is there an error, and what is the sync that is happening. And during the cutover, just we need to make sure that source system is stopped and final replication is completed. Then only we have the disk ready. So just once we have the disk and the application completed, we can just launch the targeted AWS servers on the AWS, like SAP workloads, HANA data, any database. So we'll see what type of databases, operating systems, or what type of cloud infrastructure does Cloud Endure support. So Cloud Endure supports any type of application like Microsoft SharePoint, Active Directories, Exchanges, Apache servers, etc. So it also supports any type of database like SQL, Oracle, SAP HANA as well, and MySQL, and these are the databases that it supports for migrating. And also it supports a Little Indian operating system that is compatible with AWS. And also, so this tool can be used where our on-source on-premise system is running on a VMware or Hyper-V or any hyperscaler, or if it's a physical data center as well. And also Cloud Endure can be used as part of DR also. So we have another option like AWS Server Migration Service. Here in this case, how this service is used to migrate using a VMware. So if we have a source system that is running on VMware, and we need to have a server migration connector installed on the source network, and we just need to connect to the VMware vCenter server, and this automatically replicates to AWS Server Migration, and this creates a export of our VMware system, total VMware system. There is no need to think about other softwares, etc. So this will just copy it from the source, and we can have the target VM ready. Once export is completed, then we can just launch the instance on the AWS side. The same way, this server migration service works with Hyper-V, Microsoft Hyper-V as well. So it supports VMware and Hyper-V. So it's the same tool where we can be used for migrating the workloads, SAP workloads from on-prem to the AWS cloud. So in case we have a HANA database on the source, and we want to migrate it to AWS. So what is the options? Like we have seen like backup restore, and we have a tool called HANA System Replication that is inbuilt with SAP HANA. So here in this case, what we do is we set up a connection between on-prem and cloud, and we use AWS Quick Launch to launch the HANA instance. Like we have seen just now, use HANA Quick Launch, how we can launch HANA instances, HANA within pre-installed that can be used for launching SAP HANA instance. So once a HANA instance is launched in AWS, and there is a connectivity where there can be two options, like we can use AWS VPN or AWS Direct Connect to connect between our on-prem and AWS cloud. So once we have established the connectivity, we can go into HANA Studio or HANA database, and we can set up HANA system replication. This helps in copying or replicating the database from the source to the target. And during the cutover, we just stop the SAP system, and once the database is totally synced from the source to target, we stop the HANA database at the source system as well, and we start the HANA database on the target side, and these operations are running on the AWS side. In this case, we can also interchange the underlying operating system, like we can migrate from RHEL to Red Hat Linux to SUSE Linux, or other way like SUSE Linux to Red Hat Linux. This is supported in this process. So now coming to heterogeneous migration. This is an overview what tool we are going to use on the source, and what we are going to do in the target, and what services we have all seen these tools during the homogeneous migration as well. So I'll explain how this can be used, achieved. Homogeneous migration, like we have a system copy that is export import methodology that is inbuilt in SAP. So we have a source system that is running on-prem, and we have a cloud that is set up, and we have a, I explained, like we can have a AWS Direct Connect or a Snowball or different method, and we take export of the source system during the cutover. We stop the system, take export, then copy that export from the source data center or cloud. Then we copy to the AWS cloud S3 bucket, and then using that export, we import to the SAP instance using SWPM software provisioning tool. And this is a process, and we can also use a parallel export import process that is also supported by software migration tool. So this parallel export import can be used to minimize optimize the downtime as well. So this is an option where we can migrate any database to HANA database. We have a tool from SAP, software upgrade manager, with the data migration option, where we can combine a Unicode conversion if our source system is non-Unicode, and if you want to upgrade and we want to migrate from a non-HANA to a HANA system as well. So this software tool can be used to do these options. And here what we do is we set up a connectivity between the source on-prem system to AWS cloud, and we run the software upgrade manager with the system move option, and on the target the system is built, and during the cutover all the tables or the data that is on the source is copied to the target with upgrade or Unicode migration as well. So this is the option. So these are the ways where we can use to migrate our SAP workloads to AWS. So you have any questions, you can have it in the chat, or you can just unmute yourself and ask.
Yeah, team, I think we're done with the module 4. If you have any questions, maybe you can unmute and we can have a discussion. So Nimisha, the participants, who are the participants, can you please unmute them?
Yes.
So we have unmuted them. Attendees, if you could just, if you have any questions, kindly unmute yourself and ask the questions, please.
See, there was a question about ECC on-prem to HANA on AWS. Yes, we have, in fact, we can migrate ECC on-prem system to AWS with HANA database. That is a system change, the OS and database change, what Kiran was talking about, the heterogeneous, where the database, underlying database and OS will be changed. And this can be also achieved with some DMO option, where data migration option, where we can change, upgrade the ECC system or just move the ECC system onto HANA.
Right, thank you. Yeah, my question was before the details were provided in the subsequent slides. Got it. Heterogeneous migration.
So, can I know your name, please?
This is Krishna Cherkuri.
Hi, Krishna. So, Krishna, were you able to follow the labs? Did you have had an issue?
I think I had an issue, but that's okay. In the general, I get the gist. That was the purpose of it. I think it rolled back. One of the parameters was not right, I think, for the stack when I was trying to build it.
Okay, so this session will be available for next 5 hours, if I'm not wrong. Arun, am I right? So
yeah, we can keep it open till end of the day.
Yeah. So Krishna, if you want to get more hands-on, that will be available for you to kind of.
Awesome. That'll be great.
Yeah.
Yeah, this content was very good. I mean, will these slides be shared? Because it's I feel bad that I don't have more people from my basis team join.
Yeah, definitely, Krishna. Our team is gonna share you across the content for you to go through. No problem.
Okay, thanks.
Yeah. Apart from Krishna, anyone has any more questions?
Vikram, looks like we do not have any new ones coming. Yeah.
Yeah, sounds good. So then we can conclude here. Thank you everybody for joining this session. I'm sure, I'm hoping that this might have provided you the adequate information to move on SAP workloads to AWS. So any closing comments from any of team, please go ahead. Very well.
Thank you all.
So, yeah. Sorry, who was that?
I was just saying thank you.
Yeah, thank you. Thank you so much. Yeah.
Great. So shall we close the session for the day, please?
Yeah, please go ahead. Yeah.
Yes. Thanks, everyone. Thank you to the attendees and the panelists for taking time to join the session. Have a good day, everyone.
Thank you, YASH team.
Thank you.
Thanks,
Thank you, AWS team as well. Thank you.
Yep.
Thank you.
Thank you.